Check, am I audible to you? Please confirm first.
Yes, sir.
Hello? Okay, thank you. So in today's lecture, we are going to discuss like the free undamped single degree of freedom vibration systems. So first of all, you should have to know like what is the degree of freedom. Then we will discuss about what is the meaning of discrete systems and continuous system. Please remember this continuous systems are nothing what you can say the distributed systems. Continuous systems is having the degree of freedom is infinite. How much? Infinite. And please remember in continuous systems, the displacement or you can say the frequency or you can see the other parameter is a function of you can say two things. One is a space and one is time. When in discrete systems, we are having the finite degree of freedom. What the degree of freedom is going to be? It's a finite. It may be 1, it may be 2, it may be 3, it may be 100, it may be 1,000, or it may be 2,000. And the displacement at any point in the system or in a body is the function of space and time. But in case of discrete system, this is the function of time alone. Okay, so let's start with this today's session. And at the end, we are going to discuss all the PYQs which they have asked in your GATE Aerospace exam. Okay. Now, before starting, let me show you how many questions we are going to solve in this lecture. This is the very first question which they asked in GATE 2007 regarding like what is the degree of freedom is going to be for the continuous systems. Then this is also kind of, we can say, degree of freedom. Then again, GATE 2007 question. Then GATE 2010 question. Then GATE 2011. Then GATE 2013. Then GATE 2014. Then GATE 2015. GATE 2016. Then 17. 18. In 18, I think they asked 2 questions from this single degree of freedom systems. Yeah, for 1 mark. Here, this is for 2 mark. Okay. Then GATE 2019. Then this is the question which they ask in GATE 2021. This is very easy question. Just you should have to understand like what is the concept. Then this is the last question which they ask in GATE 2025. So let's start. And you should have to answer. I'm going to ask 3 questions. Okay, since it's a revision only, right? So yes, any problem? Addition should be white. Okay, sweet. Okay, make it white. No issue at all. Now, let's start. Tell me, what is the degree of freedom? Anyone? Yes, Nakul.
The number of variables that can define the number of independent functions that are.
Okay, Ajay, what is the degree of freedom? What is degree of freedom?
Independent coordinates to describe the motion of vibratory system.
Okay. And what about BD? What is degree of freedom? What is degree of freedom? Yes.
Degree of freedom is a number of independent coordinate which describe system position and configuration.
Okay. So you can see, and Anamika, are you there in the class? Anamika?
Yes, sir.
Yes. What is the degree of freedom?
So degree of freedom is the minimum number of individual coordinates needed to fully describe a system's configuration or its motion.
Okay, very good. So you can define the degree of freedom of a system is nothing but you can say the minimum number of independent coordinates required to specify or to describe the motion of a system completely. Now, based on this, we can have two types of the system. One is continuous system. Which one? Continuous system. Continuous systems. Now, in this continuous system, second one is nothing but I can write that's a discrete systems, right? Done? Please check. Check, please. It's a discrete systems. What it means by discrete systems? In discrete system, we are having finite degree of freedom. Here we are having infinite degree of freedom. Degree of freedom, I'm saying it's a DOF, that's an abbreviation form. Now, what are the example of this continuous system? Let's say if we are having any bar having the mass m, here in this case, the mass is distributed throughout its length. Again, you can say the mass is the function of space, right? So at this point, you may consider any element at a distance of x from here. You can consider that the length of that particular, you can say the element is nothing but dx. So what is the mass? Mass is nothing but again density into volume only. So we can define the mass at a distance of x for this element of having very infinitesimal small length dx. We can write it's a density into its area times of like what is the length of this element which we are considering, it's a dx. So you can write n equal to rho a dx here. In this case, here, the displacement x is the function of both. It's a space and time. Now, this is space we can define. It could be the 3D, it could be 2D, or it could be 1D, and time we can take. It's nothing but you can say t. So in lower engineering classes, generally we are strict with x here is the function of, you can say, the one-dimensional parameter. So you can consider, let's say, the displacement of this body, or you can say this elemental mass dm is nothing what you can say in this direction. So this is nothing what you can say longitudinal direction only. Which direction? Longitudinal direction. Second case is what? Let's say if you are considering it's a beam. What we are considering? Beam. So in beam, in which direction the displacement may take place? You can see in the transverse direction. So here, the vibration of this system is going to be like this only in transverse direction. Third one is what? Third one, it could be a shaft. So in shaft, which kind of displacement generally it will feel? You can say it's a angular displacement. So if you are applying any external torque, this body will twist something like this. Is that clear? Is it visible to you? This angular displacement is visible or not? If suppose if I'm applying any external torque, then as you can see, the twisting of this component takes place. Done. Is that clear or not? So please remember, U is also a displacement. W we are considering, or you can say Y we are considering, that's nothing but a transverse displacement. Generally, we used to call that's a deflection. Theta is nothing but you can say it's an angular displacement, but that's nothing what you can say that's an angle of twist of this particular shaft, or you can say this particular component. Done? Now, so please remember, it is a function of, let's say, that's a x, comma t, or let's say if we are considering the displacement in x direction as a u, displacement in y direction as v, and displacement in z direction is w, we can define x is the function of, you can say, u, comma t here. And please remember, to specify the motion of, you can say, the continuous system, we need the partial differential equation. What is required? Partial differential equation. Why? Because there are two variables, or you can say the displacement, or you can say the elastic properties, or you can say other parameters, the function of, you can say, two variable. That's nothing what you can say the space and time. So what is needed to describe the motion? You can see the partial differential equation. But in this case, discrete system, we may have the finite degree of freedom. Means Its a degree of freedom is not going to be infinite. Meaning what? It could be 1 degree of freedom system. It could be 2 degree of freedom system. It could be 3 degree of freedom system, or it may have the 100 degree of freedom, or it could be 1000 degree of freedom, and so on. But one thing is certain. What is that? It is having the finite degree of freedom. Now, one more thing, this system we can also call, it's a continuous systems, or nothing what you can say, these are the distributed systems. Which system, bacha? Distributed systems. Means what? In this case, you can say the continuous system or the distributed system is the actual case. But we have to idealize the structure. So which technique we generally use? You can say we use the discretization of the system, or you can say the discrete system to analyze any component. What happens here? Generally, we consider the mass is lumped, or you can say the concentrated at a single point instead of you can say the distributed case. So in this case, generally here you can write the mass is lumped or concentrated at a point. Here what happens? The mass is distributed throughout the volume, or you can say depends whether you are considering 1D, 2D or 3D system. Okay, done. Now, could you tell me what is the degree of freedom? Let's say we can consider few examples here. Let's say if I'm having any system like this. Let's say it's a spring having the stiffness K, a mass is M attached to it. Another case you may consider mass M1 third case you may also consider please draw it. Consider this is K1, K2, K3, K1, K2, K3. You may also take one more case. Let's say we are having one pendulum like this, and I'm describing the mass is concentrated at this particular point, or you can say weight is concentrated. That's nothing what you can say M. Another case we may also consider, let's say if we are having any aerofoil like this. Okay, consider one more case. Here I'm considering the mass here is nothing what you can say. This is a string, or you can say the attachment. I'm considering this mass is negligible. Negligible mass. Third case I'm considering, let's say if we are having any pendulum which is connected by a rod having the mass capital M, and let's say it is oscillating about this particular point. You can see this is nothing but pivot, or you can see the hinge. Now, how many masses are there? Sometimes students get confused if they consider the degree of freedom is equal to the number of masses present in the system. That's a wrong concept. Second thing, you may also consider, let's say we are having two masses, something like this. Let's say M1. Here, let's say I'm saying this is a rigid link, or you can say a rigid rod, which is connecting the two masses like this, M1, M2. And let's say this is K2, and this is nothing what you can say K1. Now tell me, what is the degree of freedom of this body is going to be? Yes, anyone? What is the degree of freedom
1.
of this system is going to be? Yes, please. What's the degree of freedom? You can say
1.
here. In which direction this body can vibrate? It can vibrate, you can say, in this direction. So which kind of vibration is this? You can say it's a longitudinal vibration. Which vibration? Longitudinal one. Or you can say the translation motion takes place in this particular direction. So here we can consider just only one, you can say the independent coordinate is required to specify the motion of this system completely, and we can define the degree of freedom of this system is going to be 1. Now, one more thing, which kind of system is this? Is it continuous or discrete? It's a discrete system. Okay, please remember in discrete systems, we are having the finite degree of freedoms. Okay, so it could be 1 degree of freedom system, it could be 2 degree of freedom system, it could be multi-degree of freedom systems, right? Now, one more thing, generally during the analysis, we consider the spring is weightless, or you can say the massless. Is that clear? What we consider? This is our very first assumption we take. We generally neglect the mass, or you can say the weight of the spring. For example, this is the unstretched, right? Position, or you can say the length of this spring. Now, because of its own weight, the elongation of this spring takes place. Is that clear? So which force is this? This is simply, you can say it's a gravitational force, or you can say the weight of this component only, or the weight of this system only. Done? So we are considering the spring is weightless here. Now, how many independent coordinates are required to specify the motion of this system? 2.
2.
Let's say this is nothing but having the displacement is x2 here, minimum, right? x1. So what is the degree of freedom is going to be? Degree of freedom of this is going to be 2. Done? Here also, what is the degree of freedom is going to be? Here the degree of freedom is going to be here. Let's consider the displacement here is x1. The displacement of mass m2 is x2 at any instant or time, and this is nothing but against the x3. How many independent coordinates are required to specify the motion of this system? 3. So what is the degree of freedom is going to be? 3 here. Now, in this case, which kind of vibration takes place? You can say it's a longitudinal, or you can say it is in transverse direction. But in this case, what happens? If you disturb the system, since it's a hinge, or you can say pivoted about this particular point, so what are the possibilities? It can start oscillating something like this. So here, what are the coordinate? Coordinate is nothing what you can say theta here, means the angular displacement. Again, displacement is there, but which displacement is this? This is nothing what you can say, it's a angular displacement. Again, this degree of freedom here is going to be 1, right? One more thing, let's say we are having another system in which I'm considering, let's say this mass or concentrated mass m or point mass m is suspended from this point P, or you can see the point O, by a rod having the mass capital M. Then how many masses are there? One individual mass of this, you can see the point, or you can say this concentrated mass small m, and the mass of this rod is nothing but a capital M. So if you displace this body, let's say this is the center line. Let's say if you are displacing this body, then it is going to be like this. This is M and this is capital M. Now, here, what is the weight of this body is going to be? Weight is always x vertically downward. That's nothing but you can see the gravity force. Here, this is nothing what you can see mg, and that's nothing but a capital mg. So to specify the motion of this system, the only coordinate, or you can say the independent coordinate is required is nothing what you can say theta. So again, the single, what is the degree of freedom of this system is going to be degree of freedom of this system is going to be 1 only. One more example, I'm saying this is the rigid link. Which link? Rigid link here. Now, if I'm describing this particular component as a rigid, let's say it's a rigid bar, right? Tell me what is the stiffness of this particular, you can see the body is going to be. If I'm describing it's a rigid bar, could you tell me what is the stiffness of this body is going to be? Or what is the stiffness
Infinite.
of it is going to be infinite. How to describe the stiffness? K is nothing but you can say F divided by delta. So obviously, if any force is acting over this, there is no deflection of this body take place since it's a rigid body, right? It will not elongate, it will not deflect, right? So in this case, this delta is going to be 0. It means that this K is going to be infinite. How much? Infinite. So in this case, there is no relative motion. Let's say if I'm displacing this mass M1 by a displacement of X, then this rigid link, or you can say this mass will also displaced by an amount of X only because of, you can say, this rigid link. Means there is no relative motion between the two masses M1 and M2. So again, the degree of freedom is going to be 1 in this case also. Is that clear? Now, one more thing which I want to describe here. Could you tell me like how to calculate the equivalent stiffness, or you can say the equivalent stiffness? And another thing, let's say if we are having the dampers, what we are having? Dampers. So we have to define like what is the damping coefficient of these dampers, right? So generally we take the damping coefficient, or we denote it by capital C, right? And the stiffness of the spring generally we define by capital K. If suppose it's a torsional stiffness, generally we take the notation for this as a K suffix theta, right? So this is nothing what you can say. That's a torsional stiffness. Okay. And what is this K theta? Anyone? What is a K theta? Sorry. It's a very good T upon theta. And what is K we are considering? K we are considering. So this is, you can define, this is nothing but a linear K u is equal to F upon delta. Okay. So this is the torsional stiffness, and you can define this K is nothing but you can say linear stiffness or simply stiffness only. Done? Check please. Is that clear or not? Now, let's say if I'm defining capital C is nothing what you can say. That's a damping coefficient. What? Damping coefficient. Yes.
वैल्यू क्या है?
Yeah.
तो मतलब एक सिस्टम में
हाँ.
कितने मासेस इंडिपेंडेंट मोशन कर सकते हैं?
Exactly. Yes.
तो जैसे वो कॉन्फ़िगरेशन इसमें रिजिड लिंक है.
Yes.
तो वो सिस्टम एक सिंगल मास की तरह बिहेव कर रहा है.
Exactly.
तो दोनों मास
means there is no relative. Yes. So there is no relative motion between these two. For example, if you consider this case, right? Let's say, okay, just give me a second. I can show you. I can demonstrate it. Just wait. Do you have any weight? Just give me a second. Just hold on. Let me show you. Okay, shall I demonstrate? If you don't mind, let's see. Is it visible to you? Hello? Those who are live,
Yes,
please
sir.
respond. Okay. Let's say we are having the system like this. Okay. And I'm attaching one more mass here like this. Is this visible? Is this visible to you?
Yes,
Let's
sir.
say we are having two masses like this. Okay, done. Now is it visible? Second mass is visible to you or not? Okay.
Yes, sir.
So here, let's consider if I displace this body, let's say this is in the equilibrium state, and if I displace the second mass, let's say the displacement you may consider here is x2, then the displacement of the first mass is going to be x1. They are not same. They are different because some energy is stored in this spring. So because of, you can say, the second spring here, there is a relative motion between the mass m1 and m2. So if I like stretch it and remove, then as you can see, the independent oscillation of the two masses takes place something like this. Is that clear? So what is the degree of freedom is going to be? In this case, the degree of freedom is going to be 2. Let's say if I connect these two masses by a rigid link, if suppose it's a rigid link, something like this, okay? If suppose it's a rigid link, where is my scale? Okay, no issue. Let's say if the second mass is attached to this particular body by a, let's say this is another system. Let's say it's a rigid bar I'm considering, or you can say rigid link. And if I connect a mass m2 at the end of it, something like this, then the motion of, you can say, these two masses are not different. It is same. So if I'm displacing this body by an amount of x, then the same amount of the displacement is also experienced by the second mass. So that's a, you can say, understanding of the rigid link. Means there is no relative motion between the two masses. So if it is, degree of freedom in this going to be 1. Clear? Okay. Now, let's revise. Let's say if the springs are connected in series like this, let's say the two springs K1 and K2 are connected like this, and the mass here is nothing what you can say m. Now, which mass we are considering? We are considering it's a concentrated mass, or you can see the point mass, right? Again, it's a discrete system. What's the degree of freedom is going to be 1 only. But now we want to know, like, what is the equivalent stiffness of the spring is going to be in this particular system. So that's nothing what you can say m I'm considering, and this is nothing what you can say ke. So in this kind of the system, could you tell me what happens if suppose this mass is displaced by x in the downward direction? Could you tell me what is the displacement along the spring K1 and K2 is going to be? Is it going to be, okay, for example, I'm considering the displacement of this spring is x1 and the displacement of this spring I'm considering it's a x2. Tell me what will happen. X1 is equal to x2 is equal to x, or x1 is not equal to x2, is not equal to x. What is a possibility in this case?
X
Not
equals
equals
to x1 plus x2.
Means here, let's say if I apply a external force, or you can say momentary force of capital F in downward direction and just release it something like this. Let's say the system is like this. Okay. So this is the equilibrium position of this. If suppose if I displace it, right? If I'm displacing, then what happens? Since there is a single spring, so in this case, the displacement of this mass is exactly equal to the elongation of this spring. But let's say if we are having the n number of springs, let's say the two springs are there. Here is that spring. Let's say two springs are there, which are connected in series like this. Okay. We are having two springs here. This is the first. Okay. Consider this is the second spring and this is the first spring. Done. So in this case, if suppose if I elongate if I displace this body by x, as you can see, the displacement in the second spring and first spring is not going to be same. Why? Because these two springs are connected in series. Is that clear? But in this case, the force experienced by the first spring and the second spring is going to be same. So in this case, the displacement is distributed. What? You can write x equal to, if x is the displacement of this mass, we can write x equal to x1 plus x2. And you can say the force is going to be same in this case. But in case of the springs which are connected in parallel like this, let's say this is K1 and this is K2, mass is M. Let's say if this is displaced by x, what happens? Let's consider the deflection in this is nothing but delta 1, delta 2. This delta 1 equal to delta 2 is going to be x. And what happens? This force, external force, F is going to be how much? You can say F1 plus F2. Now, the parallel system could be, you can see this is also one of the form by which we can describe the parallel springs. Mass M here. This is K1, this is K2. Then we can describe the equivalent stiffness as a Ke mass M. And one more thing, both are equivalent. Another case is something like this. Let's say the two springs are connected like this. Done. So whether you are considering this case or this case, both are representing the parallel combination of the spring. How? Let's say if you are displacing this mass M in the downward direction, right? Then the elongation of spring K1 is exactly equal to the contraction of second spring having the stiffness K2. At the same time, the displacement of mass is also equal to it. So if you are considering this is delta 1 and this is delta 2, right? And this displacement is x, then definitely it will satisfy this particular condition. Okay? Is that clear? Now, so in this case, generally we define this equivalent spring stiffness Ke equal to K1 plus K2. Is that clear? And in this case, we generally get the expression 1 upon Ke equal to how much? 1 upon K1 plus 1 upon K2. So the question is that, could you prove this relation? Could you prove this? How to prove it? Anyone? Yes? What's the approach? With the help of this one only. Like what you can say? In this case, if I'm considering, let's say, that's nothing what you can see. X is the displacement. Okay, make it lambda 1, delta 1 and delta 2. That's better. Yes, prove it. Let me check how many of you can prove it. Yes. Try that. Let me check whether you revise these all things or not. See, if I'm considering the deflection of this equivalent spring is delta, what I can write? I can write here delta equal to delta 1 plus delta 2. Are you agree with me? Yes. First say yes or no, sir. Now, what is this delta? Delta is nothing but you can say the deflection, right? Or you can say it's elongation, or you can say the contraction, or simply you can say it's a displacement of spring only. Now, in this case, could you tell me what is a delta 1 value and what is a delta 2 value is going to be? Delta 1 value you can define. That's nothing but you can say F1 upon K1. Done? Because K K u is equal to what? F divided by delta. So from here you can write delta 1 is equal to this one. Similarly, could you tell me like what is this delta 2 is going to be? That's a F2 divided by K2. Done. Similarly, could you tell me like what is a delta value or delta value for this is going to be? I'm considering this equivalent stiffness of this spring is Ke. You can write simply delta U is equal to F divided by how much? That's a Ke. Just substitute these values here. Definitely we'll get this particular relation. And how to cancel out? Here you can consider this F1 is nothing but you can see the F2 U is equal to F. Is that clear? Best example. Let's say the two bodies, consider this is the first body and this is the second body. Let's say if I'm stretching my hand something like this, then the force experienced by, you can see this part is exactly equal to the force experienced by this particular part. Since even if you're considering the shaft, is that clear? Then what happens? In this case, the force experienced by this shaft as well as this shaft, or you can say this bar and this bar is going to be same only. Done. But the elongation is not going to be same. Is that clear? They are different. So here, to substitute this value, you can write that's nothing but you can say F divided by Ke U is equal to F1 divided by K1 plus F2 divided by K2. Since you know F U is equal to F1 U is equal to F2. So here I can write that's nothing but you can F1 upon K1 plus 1 upon K2. If you simplify it further, definitely we can write F upon Ke U is equal to F upon F in bracket 1 upon K1 plus 1 upon K2. So this F and this F get cancelled, and ultimately we are getting the relation 1 upon Ke U is equal to how much? 1 upon K1 plus 1 upon K2. Please remember, the displacement is a vector. Is that clear? Where this concept is needed, if suppose the springs are connected at an angle, or the spring is making an angle to the direction of motion of any mass, displaced mass, something like this. Let's see if we are having any system like this. Let's define. This is any body. It can move like this, and a spring is connected like this. And I'm defining this angle as a alpha in this case. Let's say the mass is m. Consider this is k, this is also k, and this is also k in this case. Then we are having 2 to 3 approach to answer, you can say these kind of the question. We can use, you can say our equilibrium method. Just write down what are the forces which are acting over it. Apply the equilibrium method, like summation of inertia force plus external forces should be equal to 0. You will get the relation. Or simply from the basic understanding of, you can see the parallel system also we can write. Please remember, displacement and the force both are vectors. They are not. Yes, scalars. They are not scalars. Means what? If you are displacing this body, or you can say mass m by a displacement of x. Now, since these springs, these two springs here are connected in parallel, and then one more spring is there, that's nothing what you can say in series 2, you can say the combined stiffness, or you can say equivalent stiffness of these two springs. For example, if I mark here, then I can write down so this is nothing what you can say K and K both are connected in what? Series or in parallel? Parallel. So what if this stiffness is going to be combined? It is going to be 2K, right? And this is going to be what? K. At what angle they are acting? At an angle of alpha. Then if you are displacing this mass by x, then the displacement in this spring is not going to be same. Are you getting? Vectors are what? Could you define the vector? Yes. Yes, yes.
Having both magnitude.
In vectors, generally, we have to describe two parameters. One is what? What is its magnitude? And second one, you can see it's a direction. Is that clear? So obviously, if you want to calculate what is the equivalent stiffness of this system is going to be, I can write down, this is going to be, let's say it's a KE. Could you tell me how much you will get? 1 upon 2K plus 1 upon K. How much you will get? In this case, 1 upon KE is equal to how much? 1 upon 2K plus 1 upon K. Or you can also describe this one as, see, if the two springs are connected in series, I can write on KE is equal to how much? K1, K2 divided by K1 plus K2. Is that clear, guys? Now, here, I can also calculate KE is equal to, that's the K1, K2 divided by K1 plus K2. So you may consider, let's say, this is K1 and this is K2. So simply you can write, that's nothing what you can say, 2K into K. How much you will get? 2K square divided by 2K plus K. How much? 3K. This K and this power is gone. Ultimately, you can write K is equal to how much? That's a 2K by 3. Is that clear? Now, so this K is nothing what you can say. That's a 2K by 3. Now you are in position to calculate, like, what is the nature frequency of the system is going to be. Tell me how much we'll get. Yes. See, if this mass is displaced by x, and since this spring is making an angle alpha to the direction of motion of, you can see, the mass m, then what is the displacement in this direction is going to be? First of all, if suppose if you are displacing this body in this direction, obviously what happens? Elongation of this spring will take place. So what you can say, the elongation in this spring is going to be x or is not going to be x? Definitely, if I'm considering the displacement of this spring is xs, is not going to be x in this case. What is x here? X is the displacement of this mass. Is that clear? If this spring is connected, you can say like this, means it is making 180 degree, or you can say the zero angle, depends from which reference line you are going to, you can say, measure it. Then you can write the displacement in a spring is going to be the displacement of the mass. But in this case, the displacement in the spring is quite different than the displacement of mass m. So what is the displacement in a spring? This is displacement in a spring is going to be how much? If this is alpha, right, and this is x, it is going to be how much? X cos alpha. Done. Now, what is the spring force is going to be? Fs. That's nothing but k into elongation, or you can see the contraction. That's nothing but simply you can see the displacement only. So what I can write? The spring force now it is going to be k into x cos alpha. It is not going to be kx. Please take care of it. Are you getting this or not? Now, again, force is what? Force is nothing but you can say vector. Is that clear? So in this case, could you tell me what is the force which is acting? If suppose it is displaced by x, then could you tell me how much it is going to be?
F1 cos alpha.
See, that's a force you can see in this particular spring only. Is that clear? That's going to be F cos square alpha. That's correct. That's a spring force. But what is the force here? Yes. So revision नहीं किया तुम लोगों ने? हाँ? Just tell me. Yes, it's a revision class. Let me check whether you are revising the content properly or not. Yes.
MX double dot.
Take your time. I really want to hear from you. Yes. I'm not in hurry. Take your time.
So
Yes,
can you
begin.
ask the question again? Like what exactly you're asking?
Ex cos square alpha.
I mean to say, what is the force in this spring? That's in the direction of motion of this body. That's nothing but you can see the Fs cos alpha. What is this Fs? This Fs is nothing but k into x into cos alpha. Is that clear or not? So tell me, what is the force in this spring is going to be? Yes, anyone? I mean to say,
Fx cos square alpha.
sorry,
Fx cos square alpha.
that's okay. I think you are not getting what I want to convey. I mean to say, we are making this system, if we want to make this system, okay. I want to convert the system something like this, right? So what is the equivalent stiffness K is going to be? Tell me. That's what is required. I really want to know what is this K value. In reality, the system was like this. Is that clear? K, K, K. So if suppose if I want to calculate what is the natural frequency, so it is going to be how much? K by M. So I mean, what is K value in this case is going to be? How to calculate this? Yes. In the direction of motion of this particular body, if I'm displacing this by x, yes, K is going to be how much?
K cos alpha.
That's nothing but the speed. I think we have taken this is K, right? So let me mark here, it's a K prime. Okay. So what is this K prime value? This K prime value is going to be how to calculate? Yes. How to mark it? We can write simply what is the Ke prime into x is equal to how much? K prime, sorry, K into what is the x in this case? X is going to be how much? X is x cos alpha, but again, we have to take its component. So it is going to be how much? K into x cos square alpha. So just write down and find out what is the equivalent spring stiffness of this spring is going to be. So we can write the spring force in this case is going to be, let's say, Fe prime is equal to, that's nothing what you can say. Let's say F cos alpha. Now, what is F here in this case? Fe prime is nothing but that's a Ke into x is equal to F. Could you tell me what is this F is going to be? F is going to be, yes, that's a Ke we have taken, right? Into x, where F is nothing but you can say Ke into x cos alpha. So just substitute here. This is going to be how much? X cos alpha into cos alpha. So simply this x and x get cancelled. So you will get Ke values nothing what you can say it's a Ke cos square alpha. Please take care. So just remember this particular result. Whenever the springs are, you can say inclined, or you can say making any angle alpha to the direction of motion of you can say the displaced mass, then its stiffness is going to be Ke cos square alpha. If suppose it's a single spring, you can write that's nothing but a K is equal to K cos square alpha only. And if you look at the natural frequency, generally we define natural frequency in this case, I can write that's a Ke upon M. Now, omega n is going to be how much? If you substitute the value of Ke, it is going to be simply cos alpha times of how much? It's a Ke prime. I'm considering it is going to be Ke by M. So please remember the same spring. If I'm considering, let's consider a single case. Let's say stiffness is K. Mass is m. This is the first system. Consider the second, you can say, case here like this. Mass is m. Same spring. Let's say it's displaced by x, having the stiffness k. This is also displaced by x, having the mass m. Now, what the natural frequency of this is going to be? Simply I can write, if suppose this angle is alpha, simply I can write it's a cos alpha times of root of k by m. I'm considering this is the first case, I can write it's a omega n1. Is it clear? In this case, let's say it's a second case, what is omega n2 is going to be? Simply it is going to be root of k by m. In this case, whatever the displacement of, you can say, mass, in this case, I'm considering x is the displacement of this mass. Then what is the displacement? You can say this spring is going to be. It is also going to be same. Done? Means the elongation or contraction in the spring is nothing what you can say. The displacement of this particular body, or you can say mass in this case. Here I can write omega n2 is equal to root of k by m. So if you want to take the ratio of, you can say, the first case and second case, like omega n1 and omega n2, or if you want to write down omega n1 in terms of omega n2, what I can write? Omega n1 is nothing what you can say, it's a cos alpha times of omega n2. Why so? Because omega n2 value is nothing what you can say, it's a root k by m. If suppose the examiner is asking you to calculate what is the ratio of these two frequencies, omega n1 by omega n2 is going to be cos alpha. Right? Let's say this angle I'm considering, that's a 60 degree. How much I'm considering? 60 degree. Done? If suppose it's a 60 degree, then could you tell me what is the ratio of frequencies is going to be? That's nothing what you can say. That's a cos 60. Cos 60 is how much? 1 by 2 or root 3 by 2?
1 by
It is going
2.
to be 1 by 2 only. So 1 by 2 is nothing what you can say. That's a 0.5. Is that clear or not? Provided, please remember, the stiffness of the spring is K in this case as well as in this case. Means we are not changing the stiffness, but we are changing the orientation of the spring in this case. Here the spring is connected, you can say, along the direction of motion of, you can say, this particular body. In this case, it is inclined by an angle of alpha, again, provided when they are having the same mass. Then it is going to be omega n1 or omega n1 upon omega n2 is going to be cos alpha. Is that clear? Now, the question is that if suppose instead of, you can say, the one spring, let's say 3 to 4 springs are connected in, you can say, one is making angle alpha 1, another is making the angle alpha 2, alpha 3, alpha 4. Can you like calculate the natural frequency of the systems? Yes, we can. No issue at all, right? For example, practice few questions. Let's say take this question as a homework. Mass is m. Okay, let's say this is k, this is also k, and this is also k. That's our question number 1. Second homework you may consider. Let's say same question, okay, but let me change few things. One more spring is connected like this. K, 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 K. Like this. Could you calculate its natural frequency? Here, calculate omega n, or you can see the Fn. Please remember, what is the relation between the circular frequency and linear frequency, or angular frequency and linear frequency? Please remember, this omega n is equal to how much? 2 pi Fn. Okay, done. Is it okay or not? So what is this? Fn is going to be Fn is equal to omega n upon 2 pi. Now, the main difference between omega and Fn, like how to identify. Kritika, are you in the class? Kritika?
Yes, sir.
So you were asking us, sir, like most of the time I get confused, like how to identify whether they are asking omega n or Fn. Simply just look at it's a frequency, like unit. If suppose they are asking in radian per second, then it means that what is desirable to calculate the angular frequency. Is that clear? If suppose they are
Yes.
asking in hertz, then you have to calculate the Fn. And what is this hertz? Simply, you can say this is nothing but you can say cycles per second only. What? Cycles per second. Is that clear? Are you getting or not? Okay. Here also calculate like what is the nature frequency in this case. Okay. Now.
Sir,
Yes.
दोनों क्वेश्चंस में एंगल्स θ1 एंड θ2 ही कंसीडर कर ले या आप दे रहे हो?
Okay. I'm consider 45, 45 degree and 45 degree. Consider this. Okay. Thank you. I forgot to mention like what is angle between. Shall I change the slide? Yes or no? Please confirm.
Yes, sir.
Yes, sir.
Okay. So the next question is that like what it means by the free vibrations. Anyone? Could you describe what is the meaning of free vibrations? Now we are going to discuss free undamped single degree of freedom systems. Yes, free undamped single degree of freedom systems. So what it means by the free vibrations, first of all?
So when there is no external force acting on a system, initially जो हमने displacement देने के लिए जो external force लगाया है, after that when there is no external force acting on the system and the system vibrates on its own under the effect of its own natural frequency because of its own internal elastic forces, such a vibrating system is called as a free vibrating system.
See, simply you can understand like this. Where is the spring? Can you see here? Look, springs. I think it should be here. Yeah. See, what's the meaning of free vibrations? Free vibrations you can describe it if the external force is removed after giving an initial displacement to the system, then what happens? The system will vibrate on its own, right? For example, let me give you. See, the system is like this, okay? Now, this is the static equilibrium position of this particular system. Let's say if I apply an external force on this system and immediately if I remove it, then the system starts vibrating on its own. So this is the case of what? This is the case of free vibrations, right? Is that clear? In this case, what is desirable in this system? Generally, we have to calculate nature frequencies. Depends which kind of system is this. Whether it's a single degree of freedom, 2 degree of freedom, multi-degree of freedom, or whether it's a continuous systems. Is that clear? Please remember, the continuous system is also the case of what? Undamped and free vibrations. So what is desirable in continuous systems? To calculate the natural frequencies. How many natural frequencies are possible in case of, you can see the continuous system, you know very well. It is infinite number of natural frequencies will be there. Why? Because this continuous system is made of what? Infinite number of points or what? particles. So each and every particle means vibrates on its own frequency, or you can say with different frequency. So if infinite masses means what are the possible cases? You can say the infinite number of frequencies will be there at the same time. Why we are generally so concerned about the first mode nature of frequency? Because in first you can say in the first mode frequency, we generally get the maximum amplitude. That's what is desirable. One more thing, why this nature frequency? Because we want to avoid the resonance in the system. What is the resonance condition? Anyone? See,
When
we
the
don't
frequency
want.
equals to natural
Yes.
frequency.
Okay. Come again. What he said?
When due to like external force, the frequency becomes equals to natural frequency of the system.
You can simply say if the frequency of the system is equal to what? Equal to the natural frequency of the system, then what happens? Resonance. And in this resonance, what happens? Very high amplitude of the system is desirable, right? Or you can say very high amplitude generally happens, and that's a undesirable things. So we have to avoid the resonance conditions, you can say, while you are going to design any structure like a bridge, right? Or you may consider the other mechanical systems also. So the question is that, let's say if we are having a simplest form, I'm considering the case of longitudinal vibrations. Which vibration is this? Longitudinal vibration. Calculate its nature of frequency. Calculate its nature of frequency. Like from here, you will get omega n is equal to how much? Root of k by m. And this is also equal to root of g by delta. So how to get this relation? Anyone? See, we are having 2 to 3 methods. One is what? D'Alembert method, which is nothing but against the equilibrium method. Second one is what? Energy method. And third one is what? That's a Rayleigh method. Which method, guys? Rayleigh method. But generally, in lower engineering classes, or you can see for GATE exam, just concentrate on a single method. Since maximum one question they will ask from here, right? But for academics, you should have to cover like what is the energy method, what is this D'Alembert, or you can say the equilibrium method, as well as you can see the Rayleigh method. So let's start from very basic. Let's say simply we are having one spring. So here the spring is having the stiffness K. I'm considering this is the unstrained spring. Unstrained spring. Consider a line from here like this. Is it straight or not? Almost straight. Okay. Let's say if I attach a mass M to this spring, definitely what happens? The elongation in this spring will take place. For example, see, this is the unstrained spring here. What is this? Unstrained spring. If I connect any mass M to this system, what happens? The elongation of this spring will take place. Why this elongation takes place? Because of this weight, or you can see the gravitational force. Now, so if this body is under the static equilibrium condition, what you can write? The weight of this body is exactly equal to the spring force. So if you are considering small delta as the static deflection, what is the static deflection? Find out. What is the elongation in this spring? That's nothing but delta I'm considering, right? So what is the spring force? In which direction this spring force will act here? See, the gravitational force or weight is always acts vertically downward. In which direction? In vertically downward direction. So that's a W equal to mg, which is acting in vertically downward direction. But here, could you tell me what is the spring force is going to be? Spring force is going to be in the equal and opposite direction. Why? Because it will try to restore the body in its initial, or you can say the mean position. So it is acting in the opposite direction of its displacement. If the body is displaced in this direction, then the spring force will act in this direction, right? In upward. If suppose it is contracted something like this, then the displacement, then the spring force act in the downward direction. Depends something like this. Let me show you what I want to convey. In this case, so it is a to and fro motion about its mean position, something like this. Is that clear or not? Which kind of motion is this? To and fro motion about its mean position. So the compression as well as the extension of this spring takes place, means the direction of the spring force is also keep on changing. But don't panic. You will get a single differential equation to describe the motion of this particular system. That's nothing what you can say. You will get how much? Mx double dot plus kx is equal to 0. But the question is that how to get that particular equation? That we have to derive it. Okay. So let me remind you once again. So in this case, if I'm attaching the mass, since I have demonstrated, let's say this spring is stretched. So I'm considering this is nothing what you can say, E delta. Now, immediately draw the free body diagram. Which diagram? Free body diagram. So here you can write this is the free body diagram of this particular system. Now, in this case, what happens? The weight, or you can say gravitational force, always acts vertically downwards. So W is equal to mg. Now, here the elongation of this spring takes place. It means that what? That's a static deflection, which I'm defining here is nothing but delta is in downward direction. Obviously, what you can say? The spring force will act in the upward direction. That's nothing but it is the Fs. So what it is Fs is going to be? That's nothing but K times of delta. How to calculate the stiffness? K is equal to F upon delta in this case. So F is going to be how much? If you are defining Fs is the spring force, you can write Fs is equal to, that's a K times of delta only. Done, guys? So that's what we have defined. From here also, you will get one relation. What is that? See, if this body is under the equilibrium state, it means that what? The summation of the forces which are acting over this body should be equal to 0. So obviously, these forces are acting in the vertical direction. You can write summation of forces in vertical direction is equal to 0. Now, take the sign convention. Let's say the forces which are acting in positive by direction, or you can say in upward direction, are positive. The forces which are acting in downward direction, or you can say negative by direction, are negative. So if you take, you can say the such sign convention, what I can write? I can write simply from here, the spring force minus gravitational force is equal to 0. And from here, what you can write, guys? Shall I write it here? Okay, I can write here. Fs is nothing what you can say, that's a K into delta, U is equal to how much? That's a M into G. From here, I will get one relation as a K by M, U is equal to G by delta. You can call it as equation number A or equation number 1. Now, listen carefully. So this is the new equilibrium when this body is displaced, or you can say when the mass is attached to this spring. Something like this. Now, try to understand. If suppose this is a new equilibrium, or you can say this is equilibrium state when the mass is attached to this body. Let's say I'm displacing this body by some displacement x in the downward direction. Then if x is the displacement, could you tell me like what is the velocity and acceleration is going to be? You can say dx upon dt is nothing what you can say, the velocity. d2x upon dt square is nothing what you can say, the acceleration. So what I can write, let's say if x is the displacement, I can define x dot as a dx upon dt, that's nothing but a velocity, and acceleration is nothing but x dot is equal to d2x upon dt square. Done? Clear? Sorry?
dx by dx.
Yeah, it's a dx by dt, not dx by dx. Okay? Done? Okay. One more thing. What I told you, we are dealing with the discrete systems. Which systems? Discrete system. So in this case, x is the function of time alone. But since we have discussed the continuous vibrations also, right? Or continuous systems also, in that case, the displacement at any instant is the function of what? It's a function of, you can say, two parameters. We are considering the displacement in x direction, we have considered by u, and another factor is what? Time. So that's a function of u comma t, something like this. So in this case, which kind of, you can say, or which kind of, you can say, the differential equation comes into the picture? That's an ordinary differential equation. In this case, what you will get? Partial differential equation, PD will comes into the picture, because PD comes when you are going to describe the differential equation for more than one variable, then the partial derivative comes into the picture, or partial differential equation comes into the picture, right? Please take care of it. So in this case, we can simply define, let's say this is displaced by x, then it is going to be x dot, and the acceleration is nothing but you can say x double dot at any instant. Now let's say when this body is displaced from here by x, then it is having the acceleration and velocity something like this. Now here, let me draw one diagram. Let's see. Obviously, in this case, done. So the question is that what are the forces? Let's say at any instant, what are the forces which are acting over this particular body, or you can say mass m? Then just apply the D'Alembert principle, or you can say that's nothing but you can say equilibrium method. What it says that according to this, only two forces are acting over this body. One is what? One is the inertia force, and second one is what? You can say that's the external forces. Done. Now, in this case, just remember how to mark the direction of the inertia force. First of all, what is the inertia force? That's a mass into acceleration only. And please remember, inertia force always acts in the opposite direction of movement, or you can say motion of a body. So in this case, this body is displaced in the downward direction. In which direction, guys? Downward direction. It means that this is the direction of motion at an instant. Then could you tell me, like, what is the direction of inertia force is going to be? I can write this is the direction of inertia force, or I can write this is the direction of inertia force. Done. Is that clear or not? This is the direction of inertia force, and in this case, if this is the direction of inertia force, could you tell me, like, what is the direction of spring force is going to be? It is in C. If this body is displaced in downward direction, obviously, what happens? The spring will try to bring this body back in its equilibrium position, or you can say the mean position. So here, this is nothing but you can say the F spring. What is that? See, how much total deflection we have applied to this body. Look, I'm considering this is nothing but you can say X. So if you are considering the displacement from this, the total deflection is going to be how much? That's a x plus delta. Is that clear? Done? First say yes or no, sir. And what are the forces which are acting? If I'm considering the static deflection in this case, then the total spring force I can write that's a k into x plus delta. Check. Done? What is the inertia force in this case? You know very well, inertia force is nothing but you can say mass times of acceleration. So if mass is m, we have defined the acceleration as a x double dot. I can simply write it say mx double dot, right? So this is nothing but you can see the free body diagram. So in undamped free vibrations, whether it's a case of you can see the angular motion, or you can see the linear motion, or it could be the case of you can see the transverse vibrations, what is needed? Just only the equilibrium diagram, or you can see the free body diagram of a component. If you are in position to mark, you can say the free body diagram, it means that you can write down the equation of motion of this system very easily. Now, what is the assumption we are taking? We are considering the forces which are acting in the upward direction are positive. The forces which are acting in the downward direction as a negative. So in this case, the inertia force as well as the spring force are acting in the same direction. It means that what? Just simply apply that on according to the D'Alembert principle, or you can say the Equilibrium method. What I can write? Summation of inertia force plus external forces should be equal to 0. So what are the inertia force here? That's a mx double dot plus what is the external forces in this case is going to be anyone? Yes. That's nothing but you can say the spring force only. So that's a k in bracket x plus delta u is equal to 0. Is that clear? Please check it. One more thing. If we are considering here, that's what I want to convey. If we are considering the static deflection, then definitely we have to consider here the gravitational force also. What is a gravitational force? That's a weight of the body. So what is the weight of body here, which is acting in the vertically downward direction? So please remember, the external forces could be more than one. But the inertia force is what? Mass into acceleration. That depends. How many bodies? How many bodies are present in the system? Whether it's a 1, 2, or 3. Clear? Okay. In this case, mx double dot plus k x plus delta. These are the forces which are acting in the vertically upward direction. But one more force is there. That's nothing but you can see the gravity force, or you can see the weight of the mass m, which is acting in vertically downward direction. So according to our sun convention, what we are considering, the forces which are acting in upward direction are positive. The forces which are acting in downward direction are negative. So I can write here that's a minus mg also. If you simplify this further, what I can write? Minus mg plus check plus mx double dot plus kx plus delta u is equal to 0. Say yes or no, sir. Hello, am I audible or not? It's a k delta times of k. I forgot to write. Right? Now, listen, what we were getting from here, we are getting mg u is equal to k times of delta from, you can see the static equilibrium, or you can see from mean condition. It means that what? It means that if I substitute either mg u is equal to k delta, right, or k delta u is equal to mg, these two terms vanished here, right? Or we can eliminate it easily. What do you have to write here? Yeah, because k delta u is equal to m into c. So ultimately, what we are getting? We are getting it's mx double dot plus kx u is equal to 0. Then I can again simplify it further, x double dot plus k by m into x u is equal to 0. So that's nothing what I can say. The differential equation of motion for a single degree of freedom system, or you can say free and then single degree of freedom system. Now, from here, you can also like understand one more thing, like how to get this natural frequency or the frequency of system. Just you have to compare this by the fundamental equation of simple harmonic motion. What is that? In case of linear systems, we can define that on fundamental equation of simple harmonic motion. Generally, we used to define x double dot plus omega square x u is equal to 0. If we compare this, what I can write? Omega square u is equal to k by m. And from here, you can write omega u is equal to root of k by m, guys. So this is nothing what you can say. That's a natural frequency. What is this? That's a natural frequency of which system? You should have to understand, because the natural frequency we can calculate for the undamped system as well as for the damped systems. And what is the relation between these two? Omega d u is equal to omega n times of root of 1 minus zeta square. So both are natural frequencies. So you should have to mark it clearly. This is nothing but you can say it's a free undamped natural frequency of the system. So here, generally we used to write that's nothing but you can say omega n is equal to root of k by n, which is defining the natural frequency of undamped free vibration system when the degree of freedom is equal to 1. Done?
Yes, sir.
So what is required? Just only the D'Alembert principle, or you can say the equilibrium method is required to calculate its natural frequency. One more question. Let's say, if suppose we are having a pendulum, what we are having? Let's say we are having pendulum something like this. I'm considering it is having the mass m, and let's say it is suspended to this point, or you can say pivot, by a weightless string or rod. It could be anything. Is that clear? What I'm considering? I'm considering here the mass or weight of, you can see this attachment, it could be the string or it could be a rod, is negligible. So in this case, what is a natural frequency is going to be? Anyone? Direct formula? That's a root of g by delta or 3g by delta. Which one is correct? Really? 3g by delta. Sorry? 3g by delta comes
Mass is
in this particular case, right? In this case, generally we are getting root of 3g by, right? 2l or l, we can calculate it. But in this case, when we are having the mass m of this pendulum, this omega n is equal to how much? Anyone? Yes, Anamika, क्या होता है? Kritika?
Root g by delta.
Root g by delta, right? So the question is that, see, this is a case of longitudinal vibration. Here, let's say if we are having any mass which is oscillating something like this, means when this body is having or oscillating something like this, or when it is having the angular displacement, then how to calculate its natural frequency? Then how to apply this D'Alembert principle, or you can say that's the equilibrium method. Please remember, if suppose it's a linear system, or you can say it's a case of longitudinal vibration, simply remember this method is easiest. Nothing is required. Inertia force plus external forces should be equal to 0. If suppose it's a kind of rotary, or you can see the oscillating motion of a simple pendulum, then simply we used to write this method as a summation of inertial torque plus external torques should be equal to 0. Very easy, or you can say simplest method to calculate the damped systems, or as well as you can say the undamped system, whether it's a single degree of freedom or multi degree of freedom, or you can say the 2 degree of freedom. Easily we can calculate, or we can have, you can say the differential equation, or you can say equation of motion of any system, whether it's a damped, undamped, single degree, 2 degree, or multi degree. Is that clear? So in this case, how to calculate its natural frequency? Simply, let's say this body, please remember one more thing. In case of linear systems, or you can say longitudinal vibrations, we were considering the inertia force always acts in the opposite direction of motion. Here, what you have to remember, the inertial torque acts in the opposite direction of motion, or you can say in the opposite direction of acceleration. Is that clear? Is that clear or not? So it is going to be what? Let's say if this mass is displaced by an angle theta, let's say I'm saying this mass is displaced at this particular location and having the angular displacement is theta, then first of all, this is the equilibrium state of this particular body. So the mass is acting in the vertically downward direction. So could you tell me, like, what is this W is going to be? This W is nothing but you can say in this case, how much? That's a M into G, right? Doesn't matter whether it is displaced at this location, or any location, the gravitational force, or you can see the weight, always acts vertically downward only. That you should have to understand. It means that I can also mark here, this is going to be W is equal to mg. How much, bacha? Is it straight or not? Okay. W is equal to m into g, or simply you can write that's nothing but you can say mg only. Done. Now we can take the component of, we can say, this weight W is equal to mg like this. This direction and in this direction, right? Something like this. Now, clear? If this angle is theta, could you tell me what is this angle is going to be? This angle is also going to be theta. If this angle is theta, could you tell me like what are the component of, you can say, the weight, or you can say mg in this direction as well as in this direction? So this component is going to be how much? This component you can write that's a mg sine theta. And what we are considering? We are considering this theta is very small, in such a way that cos theta is approximately equal to 1, and sine theta we can replace it by theta. Is that clear? Please take care of it. Done. And in which direction the motion of this body takes place? This is the direction of motion of this body. Means which one? Angular motion of this body takes place. Done. Another component of this you can mark here. That's nothing but you can say it's a mg cos theta. So what are the forces which are acting over this particular body? And please remember, whenever the body is oscillating or vibrating like a pendulum, then one more parameter comes into the picture. That's nothing but you can say the mass moment of inertia. Which moment of inertia? Mass moment of inertia. Please remember, sometimes they used to say it's a moment of inertia. If suppose it's a case of pendulum, please remember or understand it's a mass moment of inertia. But in structures, generally, moment of inertia is nothing but against the second moment of area only. Which one? Second moment of area. It could be, you can see your IXX, it could be your IY. One more is there, that's nothing but again IXY, that's a product of inertia. And another one is nothing but a polar moment of inertia, that's nothing but again say IZZ. So in this case, please remember what is required. The requirement is nothing but you can say I. That's the mass moment of inertia of, you can say, the point mass or concentrated mass. Generally, we used to write that's nothing but you can say mr square. What is r here? R is nothing but you can say like what is the length, or you can say, if suppose we are calculating the nature frequency about this point of suspension, then the distance between the mass and this point here I'm considering it's r, but in this case it is given how much? R is equal to L. So could you tell me like what is this I naught is going to be if I'm considering this point is O, I naught is equal to how much? It's a ml square. How much we'll get? Ml square. Why this I naught is required? Because while you are going to calculate the inertial torque, which one? Inertial torque, or you can say inertia torque. This inertia torque simply, how much, guys? Inertia torque is nothing but, tell me, that's nothing but you can say that's a I theta double top. Is that clear? So in this case, could you tell me like what is this inertia torque is going to be about this point of suspension? Inertia torque is going to be, that's nothing but you can I naught theta double top. In which direction it will act? So what I suggest, just simply draw the free body diagram. Which diagram? Free body diagram. Well, when this body is displaced, or you can say this pendulum is displaced by angle theta here. So just draw here. Let's say this is nothing but you can say point O. Done. What is the direction of motion? Direction of motion is like this. Where is the acceleration is acting? Acceleration is acting in this direction. That's nothing but you can say angular acceleration. That's a theta double dot. Now, you know very well, the inertia force or inertial torque acts in the opposite direction of acceleration, okay, or in opposite direction of motion. So we can write this is nothing but you can see your inertial torque. Done. Clear? One more thing. What external torque is acting over this particular body, or you can say what is the external torque acting on this system? That's nothing but you can say one of the component of the weight will try to restore the body in its mean position. What is this, guys? This is nothing what you can say. This is the, we are considering this is a mean position, or you can say it's a equilibrium position of the system. Done? First say yes or no, sir. Okay. It means that where this mass is acting at this particular point, it means that we may get one component of weight in this direction. That's nothing what you can say mg into theta. What we are considering, we are assuming this theta is very small. It means that this sine theta is approximately equal to theta only. Done? Now, so in this case, what is the direction of, you can see the external torque, or what is the external torque? External torque is nothing what you can say, this one only. What is the inertial torque? Inertial torque is here. So just apply this right on by equilibrium method, or you can say by D'Alembert principle. Inertial torque plus external torque should be equal to 0. Even the 9th, 10th, or 11th, or 12th class student can also easily understand like what is this. You can say the D'Alembert principle, or you can say the equilibrium method. Nothing is required except the explanation. Once you understand this, it's very easy to find out the nature of frequency. So here I can write simply the equation of motion. You will get I naught theta double dot plus about what point the moment, or you can say torque, it is created about this point of suspension. That's nothing of point of O. It is going to be how much? What is the length of this? That's nothing what you can say L only. So it is going to be how much? That's a mg into theta into L equal to 0. Done? If you simplify it further, I can write that's a theta double dot plus mgl divided by I naught into theta equal to 0. Done? From here, I can write theta dot double dot plus mg into L divided by, what is the I naught value? In this case, I naught is nothing what you can say ml square. Just substitute here. That's a ml square into theta equal to 0. This m and this m is get cancelled. At the same time, this L and this power is gone. So ultimately, what we are getting? Theta double dot plus g by L into theta equal to 0. So just compare this with the simple harmonic motion, or simple harmonic fundamental equation of angular simple harmonic motion is going to be how much? Theta double dot plus omega square theta equal to 0. Just compare this by the simple harmonic motion, fundamental equation of simple harmonic motion in case of angular vibration, or you can say angular displacement. We can write this omega equal to, or omega square equal to g by L. So this omega n is going to be root of g by L. That's it. Done? Hello? Am I audible to you or not? Please check.
Yes, sir.
Now, those who are on like watching me live, if you are having any doubt, please comment in chat box. Those who are live on YouTube, if you are having any doubt in this method, please comment in chat box. Okay. Now, next question is what? Let's say same case here. Okay. What? Same question. But in this case, if suppose if you are considering, see, this question is really, really very important. What I'm considering? Same question, but here let's say this is the length L here, or capital L, whatever you may consider. This is a pivot, or you can say the hinge. And here, let's say one point mass of a small m is connected and capital M is here. In this case, could you tell me like what is the nature frequency of the system is going to be? This is also very easy. Please remember, the mass moment of inertia depends upon the mass distribution, or like what is the shape and size of a particular body. At the same time, about which point you are going to calculate the mass moment of inertia, whether about the CG or whether about one of the end of the rod. Is that clear or not? Please take care. So in this case, could you tell me, like, what is the nature frequency is going to be? First of all, what is the I value is going to be? The very basic thing which you should have to ask yourself, like, what is this I is going to be? Huh? Only? Really? We are having two masses. In previous case, we have considered the attachment, whether it's a rod or you can say string, having no mass. Is that clear? But here, what I'm considering, let's say it's a rod. What is this? Let's say it's a rod having the mass capital M, and I'm considering it's a rigid rod. Which one I'm considering? Rigid rod we are considering in this case. Okay. Could you tell me what is the total? First of all, what is the I due to this point mass M about this point O is going to be? Let's consider one I we will get from this mass, another from this mass. So I can consider this I01 is nothing what you can say. Simply it is going to be ml square. Then what about this particular mass? Here we can write I0 of 2 is going to be how much? That's nothing but, you know very well, whenever if you are having any circular rod, something like this, then you know about its CG, or you can see the center of mass. What is the mass moment of inertia is going to be? ml square by
ml
12.
square by 12.
Right? But in this case, this body is vibrating something like this. So you know the mass moment of inertia about its CG. But since the axis of rotation here is different, right? The axis of rotation is nothing what you can say, one of the end of this particular rod. So how to calculate the mass moment of inertia about this particular point? Simply with the help of parallel axis theorem, just like you have studied, you can say in strength of material, or you can say in aircraft structure, to calculate the moment of inertia about any parallel axis. So in this case, you know, like, what is the mass moment of inertia about? You can say it's the center of mass, or you can say about its CG. That's nothing what you can say I0 or I about its G is going to be how much? Mass ml square by 12. Done. But you want to calculate the mass moment of inertia about the point of suspension, or you can say this point about, you can say one of the end of this rod. Just you should have to know what it is distance is going to be. Obviously, this is going to be L by 2. That's a midpoint. Is the center of mass, or you can say center of gravity. I'm considering it's a prismatic bar only. What I'm considering? It's a prismatic rod. Done. So if it is L by 2, what it is? I is equal to, generally it's a IG plus mass times of OG whole square. What is the OG? OG is nothing what you can say, the distance between the two axes here. One is centroidal axis, and this is what? This is the local axis of rotation, which is nothing but one of the end of the rod in this case. This is L by 2. If you substitute here, how much you will get? Let's say this is nothing but I0 2 is equal to, that's a ml square by 12 plus how much? Capital M in bracket L by 2 whole square. So what is this I0 2 is going to be? It's a ml square by 12 plus ml square by 4. How much will get? This I0 2 is nothing what you can say, it's a ml square by 3. Are you getting this one? Please simplify it and let me know whether you're getting this ml square by 3 or not. Please.
Yes, sir.
Yes. Are you getting? Please verify. Okay. So this I0 2 is nothing but how much? It's a capital M. Okay. In this case, it's capital L. Then it's a ml square by 3. So what is the total mass moment of inertia of this whole system when we are having the two masses? I0 is equal to, that's nothing but you can say the ml square plus ml square by 3. If you simplify it further, what you can write? I naught is what is common? L square is common now. If L square is common, simply you can write say m plus capital M by 3. Is that clear? Please check. Done? First say yes or no, sir. Okay. Once you calculate the I naught value, now write down what is the equation of motion of this particular system. Shall I ask you what is the degree of freedom of this system is going to be? It's a misconception among the student. If the two masses are present in the system, then the degree of freedom is going to be 2. No, it's not the case. It
Single
depends
degree of
upon
freedom.
like how many independent coordinates, minimum number of independent coordinates are present, or you can say required to specify the motion of a particular system. So in this case, the one independent, you can say the displacement, or you can say coordinate is nothing but theta, is sufficient to specify the motion of the whole system. Is that clear? If it is rigid, it means that what? Shall I draw here the diagram here? Let's say this is nothing but let's say I'm saying it's a point of suspension and it is this is the rod, okay, and here this is nothing what you can say mass. Done? Okay, very good. Let's say this is displaced from here from its equilibrium state or mean position by an angle of theta. I'm considering this is theta in this case. Done? So what is the direction of motion? Just specify this is the direction of motion, means the body is displaced in this direction. So if theta is the displacement, theta dot and theta double dot are nothing but you can see the angular velocity and angular acceleration of this particular body. So the question is that what are the external force, or you can say the forces which try to restore the body in its mean position. First of all, what is the weight of, you can see this rod, that's a capital mg. What is the mass of, you can say the pendulum we have considered a point mass, that's a small m. So what is the weight of this is going to be small m into g. Done? Okay. Here we can take mass always act vertically downward. So here you can say this is nothing but you can say mg. Now here if I'm considering this is Ly2, how much? Yeah, we have taken it's a capital L. So you can consider it's a Ly2 from here. So at a distance of Ly2 from, you can say this pivot somewhere here, you can say, right? Let's say that's nothing but against capital mg. Then how many masses? 2 masses. If this is mg and this is acting in vertically downward direction, could you tell me what this angle is going to be? Why the degree of freedom is equal to 1? Yes, tell me. Because we are having 2 components. Or just wait. Sorry, come again. What he said? What he said? Yes, yes. What he said? See, if this is theta, this is also going to be theta. Say yes or no, sir. This is nothing, simply I'm saying this is the axis of, you can say, this rod in its displaced position. If this is theta, then this is also going to be theta. Done? Could you take the component of the weight parallel and perpendicular to it? Here we can take the components are nothing but like this. One component is going to be in this direction. What is that? That's nothing what you can see. Mg cos theta. This component is going to be how much? Okay, if you want, you can mark the motion is like this. Okay, here in tangential direction, You can mark it like this. That's nothing but mg sine theta. Similarly, here we can also take the component. This component is going to be how much? That's a capital Mg. Take care of this. Mg cos theta. And this component is going to be how much? Yes, that's a mg sine theta. Shall I write it here? That's a capital Mg sine theta. Again, what is our assumption? This theta is very small. What it is? It's a very small. In such a way that cos theta is approximately equal to 1 and sine theta is approximately equal to theta only. Done? Clear? First say yes or no, sir. Now, if you want to write the equation of motion of this, right? Then simply apply which method? Yes, D'Alembert or equilibrium method only. For that, what is required? Just only the free body diagram. So let's consider this point is nothing what you can say O. I can mark here. This is O here. Draw a rough diagram. Done. What is the direction of motion? This is the direction of motion. So what is a theta and theta double dot? The acceleration will be in this direction. It means that what? What is the direction of inertia torque? That's nothing what you can say. I naught theta double dot. This is nothing inertial torque. At the same time, what are the restoring forces or external forces which are acting in the system? Which is nothing what you can say. One of the component of the weight, which is nothing mg sin theta, that's a tensile component, right? It will try to restore the body.
Yes.
At the same time, this mg sin theta will also try to restore this body. So just mark here, like what are these forces? And take the moment. So this is going to be how much? That's a mg theta. Why theta? Because here itself I'm writing the sin theta is approximately equal to theta only. And at the midpoint, if I mark it correctly, you can say this is going to be how much? That's a capital mg into theta. What is this distance? That's a capital L/2. And from one end to another end, what is distance of this rod? That's a capital L. Just apply. First of all, what is the rule? Summation of inertial torque plus external torques should be equal to 0. Done. So write down. What is inertial torque? Please write down it's I naught theta double dot plus what is the external torque? Either you can consider this one and this one. These two are creating the external torque about the hinge point, or you can say this pivot. That's a point O we have described. So this is going to be how much? That's a mg into theta. That's a force times of what? What is the distance between these two? That's a capital L plus it is going to be what? Mg theta times of, capital Mg theta times of how much? L/2 is equal to 0. Please try to understand why we are writing all are positive. Is that clear? We are considering here the torque which is acting in this direction are positive. So if you look at the torque created by this mg theta or small mg theta is going to be in the same direction of inertial torque. So all are positive. So if we simplify it further, I can write simply anything is common, theta is common here, right? Or theta g is common, or g theta L is common if I'm not wrong, right? So we can write that's a I naught theta double dot plus g theta L is common. What is remaining in the bracket? Anyone? That's a small m plus capital M. Please verify. Huh? Yeah, that's going to be capital M/2. Very good. Small m plus capital M/2 is equal to 0. Done. I notice here now. Yeah, I'm going to substitute later on. Okay, because if you are writing directly, then it is going to be little complex, right? So better we can substitute the value of I naught later on. Done. Now here, I can simplify it further. Theta double dot plus g L in bracket small m plus capital M/2 theta u is equal to 0 divided by how much? Divided by I naught. Is that clear? Now you can substitute the value of I naught in this case. This I naught for this whole system is not going to be ml square by 3 or ml square. It is going to be summation of these two. How much it is? That's a L square in bracket. How much? Small m plus capital M by 3. Done? First say yes or no, sir. Now, if you simplify it further, what we can write? This L and this power is gone. So what is remaining here? We are getting this value is going to be theta double dot plus G in bracket small m plus capital M by 2 theta divided by small m plus capital M by 3 times of L u is equal to 0. Are you getting this expression? First verify it. Please verify it. Are you getting this or not?
Yes, sir.
Is it easy or tough?
So
Easiest
getting
problem. How many of you are getting? Now, so this is nothing but is simply, you can say equation of motion of this particular system. Just compare this by simple harmonic motion, fundamental equation of simple harmonic motion of this case. That's nothing but omega square into theta is equal to 0. From here, what I can write? Omega is equal to root of how much? G small m plus capital M by 2 times of theta divided by how much? Small m plus capital M by 3. That's nothing what you can say. It's a radians per second. Done?
पर थीटा
So-
नहीं आएगा ना अंदर.
Yeah, extremely sorry. Theta will not be there. Okay? Just we are comparing. So the omega square value is going to be this one only. Done? Now, one more problem you can target here. Let's say if we are having, see this question they have asked in your GATE exam. Which one? Like this. Let's say this is any rod. When it is displaced by theta, I can take, let's say this is any rod. I'm replacing this by its center line like this. If it is displaced by theta here, then calculate its nature frequency. Okay, we can do that. But what I'm saying, take another case. Instead of, you can say this rod alone like this. Is that clear? This is the simplest case. We can calculate easily. In this case, what is the value of how many masses are there? Single mass is no, it's not a point mass. It's a rod having the mass small m, or you can say the capital M. So what is the I naught value is going to be? First, you should have to understand about which point you can say it is suspended, or you can say it is making the oscillation. So obviously about one of the end of this particular rod. So calculate what is the I value for a rod about its one of the end. So it is going to be ml square by 3 only. Done. So I naught theta double dot plus how much you will get? If suppose if I want to write directly, I can write it in single step. I naught theta double dot plus how much? If this is m, at this point, there are two component of, you can see, it is, let's say it's a m I'm writing, so it's a mg. One of the component is going to be mg cos theta. Another component is going to be how much? Mg sin theta. So this mg sin theta is nothing but I can say the mg theta only. So I can write that's a mg theta into how much? Moment. This is nothing but I can say L by 2. If total length is capital L in this case, it is going to be L by 2 u is equal to 0. Just write down, it is going to be theta double dot. It's very easy. Once you understand like what is the concept, divide by how much? I naught. Substitute the value of I naught in this case, theta double dot. A single step is required to answer these kind of questions. What you should have to know, like what is the approach? I naught is how much? That's a ml square by 3 times of theta u is equal to 0. How much will get? Theta double dot plus M and M is get cancelled. L and this power is get cancelled. So how much you will get? 3g divided by 2l. Is that clear? Theta is equal to 0. Just compare this by what? Tell me. By simple harmonic motion. So omega is equal to how much? Or natural frequency is going to be root of 3g divided by 12. How much time it will take to answer this kind of the question? If you understand the concept, then only this is easy. Is that clear or not? Yes. I can also make this problem like this. Let's say one spring is connected here having the stiffness k. Is that clear? And let's say this distance is nothing but you can say small a in this case. Tell me how to calculate its natural frequency. So this kind of the questions they can ask in your GATE exam. Is that clear? Take care of this. Take it as your homework. I think I have already solved this kind of the question in class, right? It's a revision plus PYQ. Homework. Done? Now, what I want to convey, look, from here, you will get the clear picture, or you can say clarity. If the rod is suspended vertically like this, then is there any kind of, you can see the external force or the external agent or artificial things is required to make this body in equilibrium state or in mean position? No. But if suppose if the same rod, this is hinge point, the same rod, if we want to keep it horizontal, what is required? A spring is required. Is that clear? What is required? A spring is required. Let's say this is nothing but what? It's a rigid body, or you can say it's a rigid rod. This is simply, you can say, it's a rigid rod having the mass capital M. Then let me show you what will happen. If it is in this position, right? Even if you connect the spring here, hello, look here. If I connect the spring, so since the body is in the equilibrium state, any elongation of the spring takes place in this condition? No. But if suppose if we want to keep this particular rod, you can say in horizontal condition like this, then what happens? Can you see? Hello? This is rigid and this end is hinged, and here I have like connected this by a spring. So if you want to make it horizontal, a external agent, or you can say the external device is required to make it in horizontal state or to keep it in horizontal state. So if suppose this body is horizontal, or you can say it is in equilibrium state, then what happens? As you can see, because of the weight of this rod, the static deflection in the spring takes place. Right now, this rod is not vibrating. Are you getting this one or not? If suppose, if the external, you can say the excitation, can you come here? Come. Now, what means by free vibration? Just apply the external force, yeah, and leave it. So this is nothing what you can say. These are the free vibration. We can calculate its natural frequency. Say yes sir or no, sir. Guys, first say yes sir or no, sir. So in this case,
Yes,
what
sir.
happens? In this case, we don't have to consider like what is the restoring moment which is coming from the gravitational force, or you can say from the weight of this body. Why? Because this body, when this body is in static equilibrium condition, or you can say mean position, the moment created by, can you hold it like this? Yeah. And hold it like this. At this end also. No. Here. Now, listen carefully what I want to convey. Look, the weight of this component is acting in the vertical downward direction. That's nothing but W is equal to mg, which lies at the center of gravity. Done. Because of its weight, as you can see, the static deflection in the spring will take place. It means that what? This body will be in equilibrium condition, or you can say mean position only and only when the moment created by the weight of this rod about this hinge point, or you can say pivot, should be equal to the moment created by the spring force. So what we can write in this case, now in this case, we can write down the moment created by the gravitational force about this hinge point O should be equal to the restoring moment created by the spring in the static condition. So what we will get in this case, or you can say in these kind of the questions, try to understand. Look, let me write here a very common case. Let's say this is nothing but, you can see the spring having the stiffness K. I'm considering this is nothing but, you can say A. And let's say this is hinged at this particular point, and I'm considering this rod is having the mass capital M and it is rigid. What I'm considering? It's a rigid only. If it is rigid, it means that what? It means that it will not deflect like this. Is that clear or not? It can move in this direction only, or you can say in this fashion only. Is that clear? So rigid means what? No deflection. So it is straight like this only. So in this case, what I want to convey, or why we don't consider, while we are going to write the equation of motion or differential equation of, you can say, this particular system, no need to consider the restoring moment from the mass of this rod itself. Why? Because this mg is already taken care by, you can say, the spring force here. How? Let's say when we are attaching this spring K to this particular rod having the mass capital M, then obviously we can consider this is nothing but, you can say, the static deflection. Okay, let me draw it. Let's say this is the understand. Let's say this is the rod at this point, right? Now, if we attach this rod having the mass capital M with this spring, what will happen? Obviously, the elongation in this spring will take place. Are you agree with me or not? Just I have demonstrated, right? That's a key. And I'm considering in this case, let's say the initial angular displacement was nothing but, you can see, the phi. Done. Now, to understand these kind of the problems, just only the school level mathematics is required. Let's say if I'm saying this is the arc AB, calculate the length of this arc if this OA and OB is nothing but, you can see, the R. Could you tell me? And this angle I'm considering, this is theta and this is R. Could you tell me like what is this length is going to be? You can say approximately, you can say it's a R into theta. Similarly, could you tell me if this is phi from here to here, right? This is A. Could you tell me what is the elongation of this body takes place because of its self weight? Yes, tell me. This is going to be, I'm considering, that's nothing but, you can say, the delta ST means this is the, or consider it say delta S. I'm considering that's nothing but, you can say, static deflection of this spring, or you may consider the delta also, no issue at all. What? Delta. So the question is that what if this static deflection is going to be? Yes, anyone? It is going to be A into phi only. From where we are getting? With the help of this only. Done? So in this case, what happens if this body is under the equilibrium state? Let's say where is the mass? It is acting at the midpoint, or you can say the CG. So that's nothing but, you can say, capital mg. Done. If this is total is nothing but, you can say, capital L, could you tell me what is this length is going to be? That's a L by 2. Are you agree with me or not? Yes. If it is L by 2, could you tell me what is a moment created by the gravitational force, or you can say weight of the rod about this point O? That's nothing but mg into L by 2. That's a torque created about about, you can say, the pivot, or you can say the hinge point O here. Similarly, because of its weight, the static deflection in this spring is nothing but delta. So could you tell me, like, what is the spring force is going to be? That's nothing but K into delta. Done? Say yes or no, sir. If this is K into delta, so you can say for the equilibrium condition, or to satisfy this body is in equilibrium state, or you can say in equilibrium condition, or to maintain the equilibrium, you can write the moment created, or you can say torque created by the spring force should be equal to the torque created by the gravitational force about point A. So let's check. It is acting in this downward direction, or you can draw here the free body diagram. Let's say it's a O. Now tell me, if this mg is acting in the downward direction, could you tell me which kind of force generated in this spring is in the upward direction or in downward direction? It is going to be in upward direction only, because of this weight, as I have demonstrated, right? The elongation in the spring takes place. It means that the spring force will act. Let's say I'm considering this A at a distance of A, you will get, that's nothing what you can say Fs, which is nothing what you can say K times of delta. So what is required, or you can say what is the condition to have, you can say, the static equilibrium condition? The moment created by this should be equal to the spring force. So if this body is under the equilibrium state, it means that summation of the moment about this point A should be equal to 0. So what is that? That's nothing what you can say. Or you may consider one more thing. Since moment is what? It's a vector. Again, you should have to take the sign convention. What I'm considering? Let's say the anti-clockwise movement is positive and counterclockwise, anti-clockwise, or you can say the counterclockwise movement is positive and clockwise movement is negative. So in this case, could you tell me which is creating, mg is creating the movement in the clockwise direction, while this spring force is creating the movement, or you can say the torque about this point A, or twisting moment about point A in the which direction? In the anti-clockwise, or you can say counterclockwise direction. So I can write here simply, that's a K delta into A, right? Minus how much? Mg into Ly2 should be equal to 0. It means that what? K delta A is equal to Mg Ly2. In these problems, no need to consider while you are going to write the equation like I theta dot plus this and that. Okay. No need to consider the mass of the rod. Is that clear? No need to consider the mass of the rod, since the gravitational force is already taken care by the static deflection of these springs. Is that clear or not? Are you getting? First say yes or no. But in case of, we can say, when the same rod is suspended vertically, we should have to take, like, what is this mg sine theta is going to be? Are you getting? Please take care. And here I haven't taken this angle phi here, since I'm considering this phi is very, very small. Is that clear? Again, what I'm considering very, very small means sine phi is approximately equal to the phi, and cos phi is approximately, you can say, 100. Please take care of this. Okay, guys. Now let's solve this problem. See, what are the possibilities? You know, shall I give you the examples? Let's say this is a rod and the spring is here. Please remember, this system and this system is same. Which one? This one and this one. So don't get confused. This is A. This is also A. So it's up to you whether you are putting this spring at the top, or you can see the bottom. But its natural frequency is going to be same. And I'm considering the mass of this rod. What I'm considering? Rod is what? It's a rigid rod. And its a mass is given here. How much? Capital M. Then question is that calculate what is the natural frequency. Done? Now listen carefully. the same question could be, what is the possibility of A here? What if this A could be? A could be L by 3, check. A could be L by 2. A could be 3L by 2. No, it could be 3L by 4, or it could be L. Means what? This A simply telling us at what location, at what location this spring is attached. Whether it's a midpoint, whether it's a quarter point, or you can say whether it's a 3/4 of its total length, or whether you are attaching this spring at the end of the rod. Is that clear? Say yes sir or no, sir. Guys,
Yes,
those who
sir.
are online,
Yes, sir.
please comment in chat box. Are you getting this one? So this is a generalized case. So it's up to you whether you are putting this spring at the end, at the midpoint, at the 3L by 4, or you can say at L by 3, L by 4, whatever it may be. Is that clear? In this case, could you tell me what is the natural frequency is going to be? Both are same case, okay? In this case, what happens? Let's say if I'm giving the initial displacement or initial angular displacement theta from its equilibrium state, where what happens? K, which condition we have satisfied? K into delta into A is equal to how much? Mg L by 2. This condition is already satisfied. No need to consider the mass of, you can say, mass of what? Tell me, mass of what? Mass of the rod. This is simply like what? In case of longitudinal vibrations, generally we used to keep on writing omega nu is equal to root of K by M. Is that clear? Even when you have considered the deflection in the spring from its static position itself, like x plus delta, still what is the natural frequency you were getting? Tell me, you were getting the root of K by M, na? Means what condition you were getting? Mg is equal to K times of delta only. So these two terms will cancel out. Similarly, if you are considering the static deflection, or you can say the angular rotation of, you can say, phi in its static condition, or you can say during, you can see the static loading, then this term and this term will cancel out each other. So no need to consider this while you are going to write, you can see the equation of motion or the differential equation for this particular system. So this is really, really very easy questions, or these kind of the questions are very easy. Second case is what? In this case, we are considering it's a mass M, and this is what? It's a rigid. Listen carefully. What are the possibility? This is what? You can say it's a rigid body. It may be rod, or you can say beam, whatever it may be. You can say it's a rigid rod. First case. Second case is what? Listen carefully. Let's say if we are having, let's say I'm considering this is nothing but, guys, you can say it's a massless, you can see rod. What I'm considering? I'm not considering the mass of, we can say, this particular rod, but let's say we have attached one mass, a small m, at the tip, or you can see the other end of this particular rod. Calculate what is the natural frequency of this system is going to be. Again, in this case, what is the possibility? What is the value of A could be? It could be L by 3, it could be L by 2, it could be 3L by 4, or it could be what? L means at what location you are attaching this spring along the length of, we can say, this particular massless rod. First say yes or no, sir. Are you getting this one? So the approach is same. What is same here? Approach is same. The only difference between this problem and this problem is that here we are considering the mass of this particular rod is capital M, and here we are considering the mass of the point load, or you can say the point mass, is nothing but a small m, and this is nothing but, you can say it's a massless, or you can say it's a weightless. So the only difference which comes into the picture in natural frequency is nothing but, you can see the value of I naught only. Are you getting? Shall I repeat? Hello? Are you getting? The only difference between this system and this system is what? Here, if suppose this body is oscillating about this particular point like this, let's say the system is oscillating like this, and one spring is attached, just wait. Just give me a minute. See, the only difference here is what? Look, is it visible to you or not? Hello? The only difference in this case is what? In one case, I'm considering this rod is having the mass is how much? Capital M. So it is oscillating like this. Done? So this A can be keep on changing. Is that clear? It could be Ly3. It could be, you can see the Ly2. It could be 3Ly4, or it could be, you can see the extreme end of this particular rod. Is that clear? First say yes or no, sir. In this case, if I'm considering the mass of this rod is capital M, then the case is like this. Second case is what? I'm considering, in reality, it is having the mass. Huh? But I'm considering neglect the mass of this. So how generally we neglect the mass? Let's say if the mass is connected here, let's say it's at 2 kg, and let's say the mass of this is, let's say it's at 10 gram, or you can say 15 gram, then we may consider, okay, it's a, in comparison to the actual mass, which is external mass M, which is attached at one of the end of this rod, is, you can say, the negligible. So we can have the natural frequency by considering the single degree of freedom only. Is that clear or not? Now, second case is what? It could be like this. Let's say, is it visible or not? First say yes or no, sir. Let's say I have attached one mass at the one of the end of this rod, and I'm considering in comparison to this mass, you can see this is negligible. Now, as you can see, the system is in the equilibrium state again, like this. So when this is in equilibrium state, it means that what? During the static equilibrium, you can say the force created by, or you can say moment created by, or restoring moment created by this string is exactly equal to what? The moment created by the weight of this external weight, capital W, equal to mg. Is that clear? So in this case, if you're considering it's a point mass, what is the mass moment of inertia about this hinge point is going to be? It is going to be ml square. But when you are considering this case, then could you tell me what is the value of I about this hinge point is going to be? It's a ml square by 3. So that's a basic difference. Otherwise, each and everything same. Now that's a sufficient to explain to, you can say, answer these kind of the questions. Shall we take this first case here? Hello, guys. Am I audible? Ajay, Vidhi, Kritika?
Yes, sir.
Anamika? Okay.
Yes, sir.
Now, let's say I'm saying we are giving a very small, you can see the angular displacement theta in the downward direction like this. Then this is the direction of theta dot as well as the theta double dot, or you can see this is the direction of motion, right? Done. Now, here, let's say this is the displaced position of this particular rod, something like this. Done. Now, in this case, could you tell me what is the elongation in this spring will take place here? That's nothing but, you can say, I'm considering that's a x only. What I'm considering? X is the displacement. Could you tell me, like, what is this x is going to be? Just I have given one, you can see the demonstration, like how to calculate this x. See, if this is theta and this is x, right? If you want to calculate this x, then could you tell me what is this x is going to be? X is equal to a into theta, na? Huh? It's very easy. First say yes or no, sir. Second thing, let's say this is the midpoint. What I'm considering? This is the midpoint in this case. Done. So what is the I naught? This point I'm considering 0 here. So what is I naught? It's a rod, right? So I naught value is how much? It is going to be ml square by 12 plus how much? M into C. Yes. About the CG, what is the value of IG? That's a ml square by 12. Then what is the distance between these 2 points? Tell me. That's a L by 2. This body is rotating, or you can say oscillating about this particular point. This is L by 2. So this is nothing what you can say OG square. So OG is how much? L by 2. Again, it is going to be how much? I naught equal to capital M L square by 12 plus ml square by 4. If you simplify it further, you can write I naught is nothing what you can see, it's a ml square by 3 only. These problems are really, really very easy. Done? Clear? Now, tell me. Just draw here the free body diagram. You can define this is the direction of motion. Draw the free body diagram. Where is the hinge point? Or you can say pivot. You can say this is the point O. Here, let's mark. This point is O here. Now, this is the direction of motion. Done? So that's the direction of acceleration. Angular acceleration theta dot. Now, in this case, could you tell me what is the direction of inertial torque? You know very well. Inertial torque always acts in the opposite to the acceleration or you can say the motion. So you can write this is nothing what you can say. That's an inertial torque. And what is this value? About which point? It is oscillating. About point O, right? So it is going to be how much? I naught theta double dot. One more thing. What is there? The spring is there. So we should have to know, like, what is the elongation of this spring? It takes place when this body is displaced by the angular displacement of theta. So what is this x is going to be? X is nothing what you can say, the a into theta, where it is lying at a distance of a. Where it is lying at a distance of a. So you can mark here, this is a. What is the spring force here is going to be? Let me define. The spring force is nothing but Fs. Could you tell me how much it is going to be? That's nothing what you can say, k into x. First say yes or no, sir. What is x here? Tell me. A into theta. Say yes or no, sir. So you can write here, that's nothing but k into a into theta. Done? Now apply which method? Tell me. D'Alembert principle or you can say the equilibrium method. Which method? Equilibrium method. So from here, what I can write? Summation of inertial torque plus external torques acting on the system should be equal to 0. So how many external torques are there? Only single one. Because of what? Because of this spring force Fs. So that's what I want to convey. No need to consider the mg which was acting at the center of gravity of this rod. Why so? Because it is already taken care by us. The static deflection of this spring. Is that clear? To maintain it in horizontal position or you can say in the mean position or you can say in the equilibrium position. So no need to write. Is that clear? Keep it simple. So here, what is the external torque? That's a I naught theta double dot plus. What is the external torque? That's nothing but a Fx. Sorry, that's a Kx, which is K into theta, Ka into theta. And what is the distance it is going to be? That's nothing but you can say A is equal to 0. Done? Bolo yes sir or no sir? So this value is going to be what? I naught theta double dot plus how much? Ka square theta is equal to 0. Are you getting this one? First say yes sir or no sir?
Yes.
And from here, what you can write? Theta double dot plus Ka square divided by I naught into theta is equal to 0. What's the value of I naught? That's nothing what you can say ml square by 3. Just substitute here. Ml square by 3 or ml square by 4? Ml square by 3. Okay. So here I can write, if I compare this, just wait. Okay, just wait. If I compare this theta double dot plus omega square theta is equal to 0, then this omega value is going to be, you know what? It is Ka square divided by I naught. What is this value, guys? This is radian per second. Is that clear? Say yes or no, sir. Ajay, are you there? Ajay,
Yes, sir.
Vidhi, and other students too.
Yes,
Could you
sir.
tell me, if suppose if I'm saying a mass m is attached at this point. Kritika, are you there? Anamika, are you there or not?
Yes, sir.
Let's say this is massless or you can say weightless. What I'm considering? This rod is weightless in this case. And mass m is attached at this particular point. Could you tell me what is the natural frequency of this system is going to be? I can say it's a 99.999. 100% this is correct. What I can write simply? I can write omega is equal to root of Ka square divided by I naught. The only difference which comes into the picture or you can say existence is nothing what you can say Very good. That's a value of I naught only. Is that clear? If you don't believe me, we can solve this kind of question also. And based on this, remember, this case, another extension case of this is nothing but, you can say this one. I called it Ajay because we discussed one more question, right? Something like this. Hello? Can you see here? Let's say
Yes, sir.
this link here is a weightless, or you can say massless. And let's say it is placed at this point M, and this is nothing but you can say H. Is that clear? And this is nothing but you can say L. Then what is required? It's a point mass, right? What it is? Point mass. You know very well what is required to answer this. Like where this mass is lies, and what is the distance between the point at which it is lying to the point about which it is oscillating, or you can say rotating. So in this case, it was L. In this case, this is not L. This is how much? This is nothing what you can say. Let me show you. This is nothing but, guys, this is going to be this only. How much it is? I'm considering it's a small L. So what is the small L is going to be? Root of L square plus H square. So even what I can write, this system is going to be equivalent of what? Listen carefully what I'm saying. I can replace this system like this. Mechanical vibration or structural dynamics is like a fun if you know the basic concept. Then what is the distance from here to here? It's a capital L. But what is the distance of this? You can say the actual mass M from this point of rotation. That's a small L we have taken. Is that clear or not? I can also draw equivalent diagram like this. This is M, and this is nothing but you can say L, which is nothing but root of L square plus H square. Nobody can deny. Is that clear or not? Is that clear? We can also make it like this. Here, this linking and consider this is again, this is a weightless, or you can say the massless. The only thing which is changed here is nothing what you can say, like what is the distance between the mass and point of rotation. Is that clear? First say yes or no, sir. So what is the case? What is I naught value is going to be? That's a ml square. In this case, what is the value of I naught is going to be? I naught means about this point O. It is also ml square. But what is the value of I naught is going to be in this case? In this case, this I naught is going to be ml square by 3. If you don't believe me, you can cross check it. Is that clear? Are you getting or not? So please don't get confused, or you should have to read the question carefully, whether it's a massless rod or it's a rigid rod having some mass small m or capital M. Is that clear? So if I want to write here, you can search on internet also. They will take 5 to 10 minutes to solve this one. Okay. Here I can write the natural frequency of this is going to be omega n equal to root of how much? Ke square divided by how much? I naught value. Please help me. ml square. Is that clear? I think we have taken it's a capital L, right? Hello? Am I audible to you or not? First say yes,
Yes,
or no,
sir.
sir. Done? Okay. When?
Point when the rod is weightless.
Where is our system? I forgot to mark here this string here. Okay, this beat. Now correct. Done? Hello? Am I audible to you or not?
Yes,
Hello?
sir.
Am I audible? And here also I did the mistake. Let me correct it. I'm considering this is nothing but you can say A. Could you mark here? Because without this string, since it's a hinge point, how to make it stable? This body could be stable when we are attaching the string in this case only. Now this is correct. It is going to be omega n equal to k square divided by ml square. Here, this is again is going to be how much? Omega n equal to root of k square divided by how much? Please help me. Where is the expression? K square divided by I naught. So this is nothing but a Ka square divided by how much? M L square. I'm writing small l square. Here I'm writing it's a capital L square. Please take care. Here, what is a small l? That's nothing but root of L square plus H square only. So
then what about the component of A? Like,
just wait. Which component of A? This A could be Ly2, it could be Ly3, it could be Ly4. For example, if you look at the question which they've asked in your GATE 2021, let me show you why I'm telling these all cases. See, this is the simplest one, right? It's a different one. This question you can solve easily. Yeah, this one. See, what is A here? Tell me, what is A? A is nothing what you can say Ly2. Ajay, are you getting? Bacho, are you getting this
yes,
one or
sir.
not? In this case, A is equal to how much? Ly2 only. It could be Ly3. So I can make, you can say 5 to 6 question, or you can say n number of questions just by changing the value of A. What is A here? A is defining like at what location this spring is connected to the rod from where? From the hinge point, or you can say from the pivot. Are you getting? So in near future, they can ask this distance is Ly2, or they can keep this spring instead of here, like here they have taken the spring here, you can say at the bottom, they can keep it here also. So the student may get confused. Is that clear or not? But please remember, both are same systems only. Whether you are connecting the spring from the horizontal, or you can say from the vertical, it doesn't change the nature of frequency. The only thing which changes the value of nature frequency is what? At what location you are putting this spring. If you look at this question again, here they have considered the mass. The spring is connected at what point? At the extreme end. Are you getting? First say yes or no, sir. Guys, are you getting?
Yes,
So in
sir.
this case,
Yes,
A is
sir.
equal to what? Capital L. It could be Ly4, it could be Ly2, it could be 3Ly4, any value of L. So if you know the basics, then I think it's very easy to understand where we were. Yes. Right. So let me show you what expression you will get. Look, from here, see, I can write omega u is equal to root of Ka square divided by I naught is how much? Ml square by 3. So what I can write here? That's nothing what you can, that's a 3Ka square divided by how much? Ml square. Done. Now look at your question which they have asked in GATE 2025, right? So the question is like this. This is the rod and spring is connected at this particular point, means at extreme end. So in this case, what happens? This A is nothing what you can say. A is defining the location of the spring. So the total length is nothing what you can say L here. Done. Say yes or no, sir. And A is also going to be L in this case. So in this case, the nature of frequency is going to be how much? 3K L square divided by how much, Larke? Please tell me. ML square. So L square get cancelled. I'm getting nature of frequency is equal to root of 3K by M. Just check. Could you tell me like what is the value of K and what is the value of M in GATE 2025 question? Let me show you like how easy it is if you know the concept. Substitute. K is given how much? 1000.
Yes, sir. 100.
100. And L is how much?
1 meter.
1 meter. But L is not required. What is mass is given? 3 kg, right? Hello? Mass is 3 kg now? Bolo yes sir or no sir? So in GATE 2025 question, they have given what? L is equal to, sorry, M is equal to how much? 3 kg and K value is how much? 100 Newton per meter. Done. Please remember, it's a common mistake which generally we used to do during the calculation. While you are using the formula omega n equal to root of k by m, m should be in what? Kgs, as well as k value should be in Newton per meter. So sometimes they will provide you the value in Newton per centimeter, or you can say Newton per mm. But while you are going for the calculation, you should have to substitute the value in Newton per meter only. Please take care of it. So if you substitute here, could you tell me like what is the omega n is going to be? That's a 3. K is how much? 100 divided by how much? 3. How much? Omega n is equal to, that's a 10 radian per second. Now, Kritika, are you there? Hello, Kritika? Kritika?
Yes, sir.
Now, let me remind you one more time. The examiner clearly asks you whether they want you to calculate the natural frequency in radian per second, or you can say in cycles per second, or you can say in hertz. In this question, it is clearly visible, na? Kritika? It is in
Yes,
radian
sir.
per second. So which one you have to calculate, omega n or Fn? Tell me.
Omega n.
Very good. So what is the answer? Here it is given 10 to 10. Is that clear? How much we were getting? 10 only. Say yes or no, sir. Say something.
Yes.
Are you getting? Okay. Similarly, in this question, right? Let me show you one more time. Just take care. The equation is going to be same whether it's a massless, or you can say with point mass at the tip of the beam. Both the cases are same only. Take care of this. Omega is equal to how much? K square divided by I naught only. Is that clear? In both the cases, what is the formula? Root of K square divided by I naught. You can remember it, then it's okay. Otherwise, hardly it will take, you can say, the 1 minute to write down the equation of motion. This one. If you are having like better understanding of this topic, just mark like what is a inertia torque, what is a spring force, take the moments, or you can see the twisting moment about the point of, you can see the excitation, or you can see the point about which this body is hinged. You will get this particular, you can say, the equation easily. Done? First say yes or no, sir. So this is also valid when I'm going to write this for which case? For this particular case. This one. Could you tell me what is omega n we are getting? Root of K square divided by I naught. Where is the mass which is acting in this case? Could you tell me? Huh? The mass is acting at this particular point, right? But please remember, we need the distance between these 2 points. It is going to be how much? It is going to be L is equal to root of L square plus H square. So this case, in this case, I can write I naught is equal to, please take care. This is nothing but ML square. This is not M capital L square. Is that clear or not? If this is L by 2, this is L by 2. What is total? Total is L here in this case. Done? What is L in this case? This one, I can write I naught is nothing but M. What is L value? That's a L square plus H square. Is that clear? Hello? Substitute this value. And what is the value of A? Here, A we have taken the location of, you can see the spring from the hinge point, or you can see the pivot. So what is the value of A? That's a L by 2. Just substitute here. What I can write, guys? It's a K. It's a L square by 4, right? I naught is how much? It's weight. It is going to be how much? 4. Yes. Tell me. I naught is M. L square plus H square. Done? First say yes, sir. Just wait. This is correct or not? So I can write omega n is equal to, I'm getting, that's a root of KL square divided by how much? 4m L square plus H square. Kritika, once again, what they're asking? Natural frequency or linear frequency? Tell me, please.
Natural frequency.
I mean to say linear
Okay.
or angular.
Angular frequency.
Why? It's a 1/2 pi.
Yes.
Yes.
Are you getting?
Yes, sir.
In simple harmonic motion or fundamental, you can say equation of simple harmonic motion is what? You can say it is x double dot, right? Plus how much? Omega square x is equal to 0. So generally we are getting the angular frequency, or you can say this is also known as what? Which frequency? Circular frequency also. Is that clear? Which frequency? Circular frequency. So we are getting the omega value. If suppose they are asking 1/2 in terms of 1.2 pi, then it's a school level, you can see the concept only, you know, omega n is equal to how much? 2 pi fn. It means that fn is equal to how much? Omega n upon 2 pi. It means that they required the linear frequency of the system, or it is in hertz. Done. So let me write here omega n is equal to, that's nothing what you can see, KL square divided by 4m in bracket L square plus H square. Done, guys? Hello, am I audible or not?
Yes.
So Fn is going to be, Fn is nothing what you can say, that's a omega n upon 2 pi. So you can write this value is 1/2 pi in bracket root of KL square divided by 4m in bracket L square plus H square. Is that clear? Which option is correct? A, B, C, or D? Huh?
A.
Which one is
A.
matching? A? Are you
Option
sure?
A.
Numerator में किया square.
Oh, here M is missing, right? Yeah, option A is correct. And what is the answer? Yeah, it is also A. Correct. So that's a correct one. But I have to prove it now. If I'm saying both the cases are same, since I've done only a single case. Which one? A rod having the mass capital M, and a spring is attached at a distance of A from the hinge point. Let's take another case when this mass lies at the one of the end of the rod, and one of the end of the rod is what? Hinged. And let's say any spring lies at a distance of A from where? From the hinge point, or you can say the pivot. So I think we have revised like all the concept, or you can say all the possible cases. Let's say this is a point about which this is a system having the mass M, and let's consider having the stiffness K, and this distance is nothing what you can say A here. So what I want to convey, okay. Before going to this, let's calculate what is this omega is going to be. In this case, omega n value, could you tell me? That's a Ka square divided by, can you tell me how much we were getting? Yeah, this one, right? Omega n is equal to root of, help me, 3Ka square divided by ml square. Now, that on case one, could you write down that on case one? What is the case? Let's say we are having the system something like this. Hardly it will take 5 to 10 minutes. Let's say this spring is connected at a distance of Ly4 from here, and the total length is nothing but capital L, and the mass of this rod is nothing but against the capital M and say rigid bar. Done. Could you tell me what is the natural frequency is going to be? Just remember this generalized case, omega n is equal to, in this case, what you can write? A is equal to Ly4. Just substitute in this formula. 3K square is correct or not? Huh? क्या बोल रहा है? आ रहा है ना? तो फिर क्यों कंफ्यूज हो रहा है? 3K, A value is how much? Ly4, but it's a L square, right? You can write say KL square divided by 4 into how much? What? Yeah, 4K square means 16, right? Now correct? So this L square and L square get cancelled. So what is omega n value is going to be? That's a 3K divided by 16m. Vidhi, could you verify please?
Yes,
Ajay?
sir.
Mohit, could you verify please? Are you getting the same or not?
Same, sir.
Questions are you in the class? No? Now, one more thing. let's say case 2. Let's say this A is equal to L by 2. What I'm saying, this spring is attached from this hinge point at a location of L by 2 from here. इसके लिए रोने का क्या है? हाँ कर ले, 5 मिनट लगेंगे. ओमेगा n is equal to root of, what is the formula? K A square 3K square divided by ml square only. Check. So what is natural frequency is going to be? Anyone? That's a 3K. A value is how much? In this case, it's a L by 2. L by 2 square means what? L square by 4? 4 ml square. So again, this L square and L square get cancelled. Again, what we are getting? The natural frequency, since we have discussed, depends upon what? Like what is the value of K, right? Hello, am I audible or not? It always depends upon like what is a K and what is the mass of the system, the stiffness and M value only. There is no length involved in this case. Why? Anyone? Tell me. Yes. Because in this case, natural frequency is not the function of what? It's not a distributed mass. It's a concentrated mass. Please take care of it. Are you getting or not? Which kind of system is this? It's a discrete system. Please take care of it. Please take care of it. Again, third case. Third case could be what? Let's say L is equal to A. This case they have asked in your GATE exam, right? Say yes or no, sir. That's a third case. What? Let's say the spring is attached somewhere here. And the mass of this is capital M. So what is omega n is going to be? Root of 3Ka square divided by ml square. Done, guys? I don't know whether I have taken a small l or capital L. Okay. So here substitute. If this is L here, then what is the location of A? In this case, A is equal to capital L means at the other end, or you can say the extreme end. The substitute the value, how much will get? This value. That's a 3K L square divided by ml square. So this L square get cancelled. What is the natural frequency is going to be? Root of 3K by M. इसके लिए क्या रोना है? हाँ, these are the easiest thing. Done? Now, let's solve PYQs. Yes. Now tell me. The sum of natural frequencies of an elastic beam with cantilever boundary conditions is, which system is this? Cantilever beam, or you can say what kind of beams we are having? Cantilever beam is there, simply supported beam is there, then fixed beam is there, then propped cantilever is there, then free beam is also there. Could you tell me, like the case of, you can say free beam, let's say if you are having the aircraft or it is flying something like this, could you tell me which kind of beam is this? It's a case of free beam. Is that clear? Shall I repeat? You can say we have to analyze it as a free beam. And what are the boundary condition of a free beam? Yes, anyone? In case of beams at the free end, what is going to be 0? What are the boundary conditions? Shear force is 0 as well as the bending moment is 0. It means that what? If y is the deflection, please remember, dou 2y upon dou x square is equal to 0 as well as dou qy upon dou x q is equal to 0. These kind of the things they keep on asking. You can say in vibrations, you can say frequently, particularly you can say in the competitive exam. Okay, whether you are going to write HAL exam or you can say the GATE exam, these things you should have to know. Like what is the boundary conditions and initial condition. So please, here elastic beam, this beam is a which system? Okay, it's a continuous system. Continuous system. If it is continuous system, could you tell me what is the degree of freedom is going to be? It is going to be infinite. Done. If it is a degree of freedom is infinite, it means that how many natural frequencies we are having? Infinite. So infinite natural frequency, if you take the addition or you can sum of those, how much will get? Infinity only. So the correct option here is infinite. Now, one more thing. Since we are dealing right now with the degree of freedom kind of questions, could you tell me what is the degree of freedom for our aircraft? or airplane? 1, 2, 3, 4, 5, 6, 100, 500. What is the degree of freedom for this airplane? See, when this airplane is means flying, means it's a motion in the space, or you can say in the atmosphere only. So what are the, you can say, the independent motions which are possible for this airplane? Look, let's say it can move, it can move, you can say, in forward direction as well as in backward direction. So you can say 1 degree of freedom in longitudinal direction. Second one is what? It can also move in the spin-wise direction. It can go up and down. So 3 translation motions we are having, and 3 angular motions are possible, and which are independent to each other. Which one is? Rolling movement, nose up and nose down, and then what? Yawing movement. So 3 rotational and 3 translation motions we are having. So what is the degree of freedom is going to be? 6 degree of freedom. Is that clear? Even if you look at the human body, what is the degree of freedom? We can say it's a 6. Which one? Let's say nose up, nose down. Is that clear? Which kind of motion is this? It's a yaw, spin wise. Really? This is rolling. Is that clear? It's a rolling. This is what? It's kind of rolling only. Say yes or no. No, it's a yawing. Is that clear? This is going to be rolling. Is that clear or not? And this is nose up and nose down. Done? So these are the 3 angular motion. At the same time, you can move in forward direction as well as in backward direction. You can also move sideways, something like this. Say yes or no, sir. And you can also move in upward direction as well as in downward direction. How? Let's say if you are climbing a mountain, or you can say any पानी है क्या? Okay, just wait. Just give me 1 minute, huh? Okay, guys. Now tell me. So it is having the right answer is what? Right answer is infinity. That's all. Each and every question. What happened? It is not moving. Second question. Second question is what? For studying wing vibration, for studying wing vibration, a wing of mass capital M and finite dimensions has been idealized by assuming it to be supported using a linear spring of equivalent stiffness K and a torsional stiffness of equivalent stiffness K theta. As shown in figure, the center of gravity of the wing idealized as an airfoil is marked in the figure. The number of degrees of freedom for this idealized wing vibration model is round up to the nearest integer. Look, simply, how many kind of motions are possible in this case? You can say nose up and nose down. Hello? Am I audible or not? Yes. Nose up, nose down. Or you can say pitch up and pitch down. So you can specify like this. It can move like this. Say yes or no, sir. At the same time, linear spring, or you can say stiffness K is also given. It means what? It can go up and down. So how many independent coordinates are there? One here you can say it's a theta. Another one you can consider that's nothing but it is x. So how many independent? Minimum number of you can say independent coordinates required to specify the motion here. You can say 2. Which one? One is translation motion, right? Up and down. Another one is what? Rotation, or you can say the angular displacement theta, which is nothing but you can say angular displacement in pitch, or you can say that's a nose up and nose up. So what is the degree of freedom is going to be in this case? That's up to 1 angular and 1 translation. Angular motion, translation motion. Angular motion means here you can say it's a nose up and nose down, and translation motion, like translation motion means what? You can say it's a up, or you can say down. Done. Say yes or no, sir. Next question. A 1 kg mass attached to a spring elongated by 16 mm. What is given? First statement. They are saying when we are having a spring something like this. So this is the unstrained spring. If you connect here a mass, let's say this mass is given here how much? We are saying it's a 1 kg mass. Let's say if you are attaching a 1 kg mass to this spring, there is another spring. Could you check? Huh? Okay. Let's say this is our spring. Try to understand. Okay. So this is nothing what you can say. It's a unstrained spring in this case. If you attach a mass m is equal to 1 kg, as you can see, the elongation in this spring is visible. No need to sense it. You can see it clearly, right? The elongation of this spring is takes place. Yes. So what is this? That's nothing what you can say. It's a static deflection, or you can say that's a static displacement in the spring. How much it is given? 1 kg mass. First we have to write m is equal to 1 kg and spring elongates by 16 mm. So what is this delta? Here you can write that's a 16 mm, and here you can mark this is nothing what you can say. It's a static deflection. Okay, the mass has been pulled from its equilibrium position by 10 mm. Try to understand, right? So this is the equilibrium position, or you can say mean position of you can say this spring mass system. Now they are saying now this is pulled by 10 mm, something like this. How much? 10 mm. So what is that? That's nothing what you can say capital X value which I'm taking. Is that clear? At what time? At t is equal to 0, and then release it. So in this case, the value of G they have provided or not? Yes, G value they have provided. That's a 9.81. So what we have to understand, omega m is equal to root of k by m. And we have already proved, right? Just you can say 30 or 40 minutes before only, this k by m is equal to how much? Root of g by delta. So it is going to be root of g by delta also. So depends like what they are asking in the question or what data they are providing. We can also get the natural frequency of the system if you know the static deflection in the spring, because in a static deflection also the body is under the equilibrium state only. Is that clear? So from here we can write omega n is equal to G value is how much? 9.81, right? Say yes or no, sir. Please take care. While you are substituting the value, what is the, you can see the basic rule or you can say the basic understanding. Your unit should be consistent. Is that clear? So G value is in what? You can say in meter per second square. And here this delta is given in mm. So you should have to make it in meter. So 1 mm is equal to how much? 10 to the power minus 3 meter. Just calculate and let me know what's the natural frequency of the system you are getting. थोड़ा प्रोएक्टिव हो जाए भाई, ऐसे आलस प्रमाण में क्यों बैठा है, जल्दी कर. How much you are getting? Tell me this value. I'm getting this value is 24.7614. Could you verify, Kritika?
Yes, sir.
Yes, sir.
Yes, sir.
24.7614. Are you getting this value? Please verify. Now, Kritika, you should have to answer. What is the unit is going to be? Yes.
Radian per second.
Why not in hertz? Tell me. Yes.
Sir, it's
Because
angular frequency.
very good. So it is radian per second. Done? If suppose they're asking like what is the linear frequency, then you can write Fn is equal to omega n upon 2 pi. But what they're asking, they're saying the response of the mass in mm is given by, means simply they are asking at any instant t, xt is equal to how we have defined or how we can define. It's a x sine omega t, or we can define that the displacement at any time t is given by a cosine function also, right? So omega value is how much? We are getting it's a 24.7614. Since here it is given, either you can say the nearest integer value or you can say up to the 2 decimal place value, right? So this value is going to be how much? 24.76 radian per second up to 2 decimal places. So out of these 4 options, we can remove option D as well as you can say the option C. Why? Because it is written 16T here. This is also written 16T. But what is the natural frequency we are getting? That's a 24.76. Is that clear? So just by calculating the natural frequency, now we are in 50-50 mode. Either you can say option A or option B is going to be correct. So what is the probability of getting the right answer? It is going to be 50% here. Is that clear? First say yes or no, sir. So that's how we have to eliminate the options. One more thing which I want to convey. Here you should have to mark. Let's say at t is equal to 0. At t is equal to 0, what happens? If you are defining this case and this case, right? What is given? At t is equal to 0, we are having the deflection, capital X. How much it is? Please tell me. That's a 10 mm. And then it is released, right? It is given 10 mm. If it is 10 mm, it means that I can write it is going to be how much? 10 sine 24.760, right? Say yes or no, sir. Or it could be, see, I really don't want to introduce here like what is a phase angle, otherwise I can also answer it. But keep it simple. Done. Apply at t is equal to 0 while you are releasing the body from the rest. Then what happens? X is equal to 10 sine 24.76 into 0. What is the sine 0 value? So according to this, they are saying when you are releasing the body at t is equal to 0, the displacement is equal to 0. Is it satisfying? No, this is not satisfying, but this is going to satisfy this particular condition, like x is equal to, it's a 10 cos 0. If you substitute here t is equal to 0, how much you will get? Cos 0. What is a cos 0? Cos 0 is nothing but 1. Sine function is having the maximum value when theta is equal to when theta is equal to how much? 90 degree, or you can say pi by 2 radian. Say yes or no, sir. The cosine functions is having the maximum value when theta is equal to 0. So x is nothing but you can say 10. So it is going to be what? X is going to be 10 only. So which option is correct here? Here it is 10. Why they are saying it is in mm? Because in this formula, I have taken x, or I'm substituting this value x in 10 mm only. Let's say if they are asking, specify, or you can say the response of the mass in meters. Could you tell me what you have to write? If suppose they want to, if the examiner is asking you to answer this one, the displacement at any instant in terms of meter instead of mm, what we have to do? Just only this 10 mm you have to write in terms of the meter only. It is going to be what? 10 into 10 to the power minus 3. Either it is going to be cos 24.76 t only. Is that clear? First say yes or no, sir. Very good. Now write on the second question. Second question is this one, right? So in this kind of the questions, what I suggest, just let me solve one more time. This is nothing what you can say. See how easy it is. Let's say I can draw here the actual one, right? So it is something like this, having the mass m. Let's say this body is displaced by an angle theta from its mean position. This is the direction of motion, right? Say yes or no, sir. Where it is mass is acting. Mass is acting since it's a lump system, or you can say it's a discrete systems, right? So its mass is acting, you can say at its midpoint, or you can say that's the center of mass, or you can say the center of gravity. So you can mark here. That's nothing what you can say. What is mass is given? Small m or capital M? Small m. So I can write here that's a mg, and this is also theta. Take the component of these and let me know like how you can mark it. Black or white. Okay. You can mark it like this. It is going to be mg cos theta. Solve it. Hardly it will take 2 minutes to answer this. It is going to be mg sin theta. Remember, what is the assumption we are taking? We are taking theta is very small. It means that what? Theta is small here, or you can say very small. It means that sin theta is approximately equal to theta, and cos theta is what? Cos theta is going to be 1. Please take care. So just draw the free body diagram. How to draw? Like this. Let's say this point is O. This point is also here. That's a direction of, you can see the acceleration. It means that this is nothing but you can say I theta double dot or I naught theta double dot. Where is this mass is acting? At the CG. So which component of this mass is try to restore this poly? Mg cos theta or mg sin theta? Definitely it is acting in the tangential direction at this particular point, right? So this is nothing what you can say. The speed. That's nothing what you can say. Mg theta. This distance is how much? Ly2 from here. Just write down. Inertial torque plus external torques should be equal to 0. What is inertial torque here? I naught theta double dot plus what is external torque? That's a force. Which force is acting? The component, that's a component of, you can say, gravitational force only. It is how much? Mg theta. And at what distance it is lying from point O? Ly2 is equal to 0. Just simplify. I can write it's a theta double dot plus mg Ly2 I naught into how much? Okay. Into theta is equal to 0. Substitute the value of I naught. How much you will get I naught value? I naught value directly you can write it say ml square by 3. Is that clear? Why? Because about the CG, Ig value is how much? ml square by 12. What is the distance between these 2 points? That's a Ly2. So what is the parallel axis theorem? It says that, let's say about point O, it is going to be Ig plus how much? That's a mass into distance between these two, OG square. If you simplify this, again, I'm repeating because I know the mindset of the student. So I naught value is going to be how much? ml square by 3. Is that clear or not? Check, check, check. Are you getting? Just substitute this value. I can simply write omega n is equal to root of how much? mgl divided by twice of I naught. Just substitute the value of I naught and let me know how much you are getting from here. You can write that's a mg is mgl divided by 2. I naught value is how much? ml square by 3. Now this m and this m get cancelled. This l and this power is gone, right? What is remaining? I'm getting this value is nothing what you can say root of 3g divided by 12. Could you verify this value, please? Are we getting the
Yes,
correct value
sir.
or different value? Yes.
Yes, sir.
We are getting this number. How much time it will take? Tell me, please, honestly. Now, in near future, what they can say? Huh? What they can ask? They can connect a spring like this. Let's say the stiffness is nothing but a K. So please, okay, consider this is A is equal to, consider it's a A, and you can consider 2 to 3 cases, A is equal to L by 3, L by 4, and capital L. Okay? Calculate what the natural frequency of the system is going to be if this is A, or you can say the spring is connected at a distance of what? A from the point of suspension. Here, it is hinged. Please take care of this. Shall we move to next question? Say yes or no, sir? Okay. So the next question is something like this. Consider a single degree of freedom spring mass system of stiffness K1 and mass M, which has natural frequency of 10 radian per second. Consider another single degree of freedom spring mass system of a spring stiffness K2 and mass M. Now, what you can observe in this case? In this case, you can observe clearly the masses of both these systems are going to be same. M1 is equal to M2 is equal to M. But here K1 and K2 value are different. That's why their natural frequencies are different. Why? Please remember, the natural frequency does not depend upon how much external force is acting on the system. It only and only depends upon what? 2 parameters. What are those? What is the stiffness? And second one is what? What is the mass of the system? Is that clear? How? Omega n is equal to root of K by M. Done? So here, consider, let's say the first case, you can mark. This is M1. This is K1. This is a second case. Here, this is K2. And let's say this is M2. So what is given here? M2 is equal to M. K2 is equal to, please help me. Huh? Why you are so silent? What they're asking? Okay, stiffness K2 they are asking, right? But what is the natural frequency? Here, this omega n2. Yes. Kritika, are you there? Hello, Kritika.
Yes, sir.
What is given? Fn2
20 radian per second.
or is it given Fn or omega n?
Omega n.
Omega n. Why? Because the unit is radian per second. Please
Radian
take
per
care of it.
second.
So omega n is how much? It's a 20 radian per second. But this is what? This is the second system we are considering. This is the first system we are considering, right? So omega n2 is given. Now look at the first system. What they are saying? Okay, single degree of freedom. बहुत बढ़िया. Stiffness K1 and mass m has nature frequency of 10 radian per second. Okay, K1. Okay, here omega n1 is given. How much it is? 10 radian per second. And here K2 they are asking in terms of what? K1, na? Okay, so they are asking K2 in terms of, or you can say like how many times this K1 is going to be. That's the question, right? So simply what you can write, omega n1 is equal to root of K1 by m1. First say yes or no, sir. So omega n1 you can write, that's nothing but you can say K1 divided by m. Similarly, omega n2 is how much? Please help me. Root of K2 by m2. What is K2? K2 they are asking, they need the relation between K2 and K1. M2 is also m. First say yes or no, sir. Okay, what is needed? K2 is needed. So we can take omega n2 by omega n1. So it is going to be root of K2 by m2 into how much? Root of m1 upon K1. Done?
Yes.
Here m1 is equal to m2, right? U is equal to m. So if you want, could you tell me what is omega n2 value? That's a 20 divided by how much? Omega n1. That's a 10 radian per second. Take the square on both these sides. I can write it's a K2 divided by m2 is m into m1 is m divided by K1. So m get cancelled. Ultimately 10 to the 20, 40 or 60? 20 only. Sometime it happens. Don't panic. 4 is equal to how much? K2 by K1. So what is the value of K2 is going to be? K2 is nothing but I can say 4 times of K1. Since I'm solving or I have to explain, like what should be the correct option? Otherwise, it take you can say hardly 1.5 minutes, or you can say the 90 seconds to answer these kind of the questions. So what are the other possibility? Other possibility is that let's say they can provide you the value of you can say the K1 and K2 natural frequencies like omega n1 and omega n2, and they can ask you like what is the mass of the system is going to be. Is that clear or not? Are you getting? For example, let's say in same question I'm considering this K1 is nothing what you can say. I'm considering say 100 Newton per meter. Okay, take it as a homework. K2 is given. Let's say this is nothing but 200 Newton per meter. Okay, keep the natural frequency same. Omega n2 is 20. Omega n1 is how much? 10 radian per second. Here, tell me what is this m2 times of m1 is going to be? Or what is the m2 by m1 is going to be? Second question. Are you getting? Hello, am I audible or not? Another
Yes.
case is what? They can provide the two spring having the stiffness K1, having the mass m1, having the stiffness K2, having the mass m2, and they can ask you like what is the ratio of their natural frequencies. So there are so many possibilities, right? Please take care. See, these are the engineering subjects. You are not preparing for UPSC or you can say any state services. It's not like a current affair, so they keep on changing. The syllabus is going to be same. Whether it's a GATE 2007, when the very first time the GATE Aerospace was introduced, or whether it's a GATE 2026, or you can say GATE 2030. Is that clear? You are not studying on the planet of Mars or you can say the Jupiter. Still, you are on the Earth only. Is that clear? Doesn't matter whether you are in Asian continent or you can say in European or you can say in any other continent. The syllabus is not going to change for aerospace or you can say the aeronautical engineering. Is that clear? Why? Because it's not a current affair. It's not a word affair. So it keep on changing. Done? Please take care of it. Hardly how much they can change? 5%, 10%. But still, you can say the 95% or you can see 99% syllabus is going to be same. So don't panic. Second one, a cantilever beam of negligible mass. Please underline this one. Okay. 0.6 meter long, It has a rectangular cross section of width 8 mm and thickness 6 mm and carries a tip mass of 1.4 kg. If the natural frequency of the system is 10 radian per second, Young's modulus of material of the beam in gigapascal. Please take care of the unit in gigapascal. So first, try to understand what is the problem. Let's say it's a cantilever beam. Okay. See, throughout the strength of material, or you can say the aerospace structure, or you can say aircraft structures, what assumption we take? We take the mass of the beam is negligible, or you can say while you are going to calculate the deflection, right? Or you can say while you are going to draw the shear force and bending moment diagram, or you can say bending analysis, generally we consider the mass, or you can say weight of the beam, or you can say component is what? Negligible, or we don't consider those masses, or you can say weight in our calculations. Is that clear or not? So what happens here? Elastic energy will restore in this particular body. Okay. So it is given L is equal to 0.6 meter. Very good. Now it has a rectangular cross section of width. So if you look at this, it's a cross section is given. How much? Could you help me? Width is 8 mm and thickness is 6 mm. Okay. So it is something like this. It is given 8 mm and this is 6 mm, no issue at all, and carries a tip mass of 1.4 kg. So I'm considering a tip mass here a point mass m, how much? 1.6 or 1.4? 1.4 kg, sorry, 1.4 kg. So immediately we can draw. So point mass means what? Please take care. Tip mass is nothing what you can say, the tip loading, or you can say the point loading. So W is equal to how much? M into G only. Now, because of the point load or concentrated load, capital W, what is deflection at the tip of a cantilever beam? That's a, if capital W we are considering it's a point load or concentrated load, then what is the deflection? WLQ upon 3EI. Is that clear? So here, this beam will deflect something like this, and this deflection is going to be how much? WLQ divided by 3EI. Done? First say yes or no, sir. Say something. First yes. First. थोड़ा पानी नहीं लेके आएगा क्या? Please लेके आना. Okay. Now, so if you know if suppose if you want to calculate the natural frequency, there are two possibilities. Either you can use d by delta, or either you can use root of k by m. Is that clear or not? First say yes sir or no sir. Say something.
Yes.
Are you getting? But the g value is here not provided, right? Thank you so much. Bus. Now, here I can write omega n is equal to, what is the value of g, guys? G is g divided by, what is the delta value? Delta value is nothing what you can say, WLQ by 3i. So what is W? MGLQ divided by 3EI. Just substitute here and let me know how much we'll get. So MGLQ divided by 3EI. This G and this G's get cancelled. Ultimately, how much you're getting? Could you tell me, please? You will get it's a 3EI divided by how much? MLQ. Say yes or no, sir. If you compare this by omega n equal to root of k by m, could you tell me, like, what is the stiffness of this beam is going to be? Yes. What is KB is going to be? That's a 3EI upon LQ now. बोलो yes sir or no sir? Hello, लड़को. हाँ? ज़्यादा पढ़ लिए क्या? Hello, am I audible or
Yes,
not?
sir.
Calculate. Now, one more thing. In which how this beam is deflecting. Tirth, are you there? Tirth, hello? Tirth, are you there? नहीं class में. Now, how it is deflecting? It is deflecting something like this. So which moment of inertia is required here? IXX or IYY? About the bending axis. So obviously, this bending here takes place in the vertical plane. So what is required? IXX is required. So IXX is going to be how much? BDQ by 12 only. To just calculate what is this IXX value? Or what is this I value is going to be in this case? I value is going to be BDQ by 12. So B is how much? 8. Well, yes sir or no sir? D is how much? 6. So 6 into 36 I can write divided by 12. 12 3 जा 36. कितना आएगा लड़के? हाँ? 6 3 जा 18. 18 into 8 कितना होता है? 144. हंसना मत अगर गलत हो जाए तो. Is it correct or not? Huh? Are you getting 144 or not?
Yes.
Online class, please say something.
Yes, sir.
Are you getting 144 mm raised power 4 or not? Even calculator is not required. You are getting the 144 mm raised power 4. Done? Please take care. While you are going to substitute the value, whether it's E, I, M, or L, your unit should be in what? K should be in what? Newton per meter, and mass should be in what? Kgs. So please be consistent with our units. So while you are going to substitute the value of length, whether it's I or you can say E is required in this case, right? You should have to substitute in their respective units only. So each and everything is known to you now. Now here, could you tell me guys, natural frequency is given or not? Yes, natural frequency of this system is given omega n is equal to 10 radian per second. So what I can write here? I can simply write omega n square from here. What I can write, bacha? It is 3 EI divided by how much? MLQ. First say yes sir or no sir. So what is E value is going to be? Please tell me. It is MLQ omega n square divided by how much? Please help me. Divided by 3I. Why we are waiting for? What is the mass? Given or not? Yes. Mass should be in kg 1.4. Length is given 0.6. I'm using SI units only. And omega n is how much? 10. So 10 square is going to be how much? Please help me. 100 divided by how much? 3 into I. I is how much? 144. So I can write here, this is going to be 144 into how much? In 1 mm, how many meters are there? 10 raised to the power minus 3. So mm raised to the power 4 is going to be what? 10 raised to the power minus 9 or minus 12? It is going to be minus 12 only. Please take care. So 144 into 10 raised to the power minus 12. Don't panic. So here you can write it's at 144 into 10 raised to the power minus 12. Now, अब क्या चाहिए आपको? Calculate it. Again, what I can write? Okay, कुछ हो सकता है? बहुत कुछ हो सकता है यहाँ पे. So I can keep 1.4 into 0.6 into 0.36, right? Say yes sir or no sir? Into 10 raised to the power कितना हो जाएगा? Tell me. 14 divided by how much? I will get. That's a 3 into 144 ना? बोलो yes sir or no sir? Or I can keep. It's a 10 raised to the power 11, and I can write here. It's a 36 into 6 also ना? If I'm not wrong. बोलो yes sir or no sir? Done? Now, even calculator is not required. 12 3 जा 36. 12 12 में 140 means 12 12 जा 144. So 12. Done? बोलो yes sir or no sir? कुछ और कर सकता है? This 3 and 3 is gone. First say yes sir or no sir? बोल हाँ या ना? कुछ मिस्टेक हो गया क्या मुझसे? Yes? हाँ? कहाँ पे? Yeah, it is going to be 6 2 जा 12 ना? 0.7, right? So what I'm getting? I'm getting E value is 0.7 into 10 raised to the power 11 I'm getting. Correct ना? क्या 0.3? Correct ना? Please verify this value. I'm getting E is equal to 72 10 to the power 9. Shall I write here or not? E is equal to how much? 70 gigapascal. Even calculator is not required. Let me help you. Look, it's a 10 to the power minus 12. So it is going to be what? 10 to the power 40. This is 0.6 into 0.36. It means that it is going to be 10 to the power 11. Now, 12 3 ja 36, 12 12 ja 144. Then 6 2 ja 12. it is going to 0.7 and 3 get cancelled. Ultimately, you are getting 0.7 into 10 power 11. If you simplify it further, it is going to be how much? 70 to 10 power 70 gigapascal. And if suppose they are asking the value of capital E in megapascal, could you tell me how much we'll get? 70 into 10 power 3 megapascal. Or let's say if they are asking in Newton per mm square, please take care. Megapascal and Newton per mm square is what? Equivalent to each other only. Is it clear? Both are same thing. Newton per mm square or megapascal. One megapascal means what? 10 power 6 Newton per meter square, or you can say that's nothing, or you can say pascals only. So that's the answer. Are we getting? Yes. Next question. Yes. A 1 kg mass is hanging from a string of stiffness 500 Newton per meter, okay, attached to a massless symmetric beam. What is given here? It's a massless. If it is massless, it means what? Elastic energy will store here. Say yes or no, sir. We can calculate like what is the stiffness of this system. So what is the stiffness of a cantilever beam because of the point load capital W, or you can say the point mass small m is going to be, that's a 3I upon LQ. In previous question we have already solved, right? Hey, what happens? Here is the question. See, what is the stiffness of this cantilever beam we are getting? That's a 3I upon LQ, right? So in this case also, I can have, since it's a massless, but what is extra here? A spring is given, which is having the stiffness of 500 Newton per meter. Okay. See, even in this question, what is given? Is it mass moment of inertia or moment of inertia? Remember, it's a bending axis. What do you mean by bending axis? Means this beam is vibrating like this only. Is that clear? So what is given? Ix is given in this case. About the bending axis, since it is bending like this only. Is that clear? Okay. So write down first given data. Mass is how much? 1 kg. What is the stiffness? That's nothing what you can say, 500 Newton per meter, attached to a massless symmetric beam of length. Again, here L is how much? 0.6 meter. Moment of inertia I, here it is given 8.33 into 10 power minus 10 meter foot. Is it correct? I'm not sure whether the data is correct or not. Let's check. E is equal to how much? 210 gigapascal. Okay. The fundamental nature frequency in radian per second of the system is going to be. Please remember, in previous case, if I want to give you more explanation, like this system could be like this. How you can replace this KB is nothing but, it is how much? 3EI upon LQ. Say yes or no, sir. What is the equivalence? This is the actual one, but while you are going for the modeling, I can replace this by like this only, by spring mass system only, where this beam is having the stiffness. That's what I'm saying. What's the KB here? K suffix B, that's the stiffness of this beam. How much? 3I upon LQ. Similarly, in this case also, I can replace this. You can see the actual system, something like this. Try to understand, okay? This is the link is. That's a 1 kg, right? It is how much? This is how much? Thickness of this beam. How much you will get? That's a 3EI upon LQ. Is that clear or not? To calculate what this KB is going to be. Okay, so 3 E value is how much? 210 gigapascal. You can answer 210 into 10 power 9. I value is how much? Please help me. 8.33 into 10 power minus 10. Online. Hello, those who are online. Could you confirm whether am I audible to you or not? Since I'm not getting the response from your side. Hello, Vidhi?
Yes, audible.
Aswit?
Yes, sir.
Yes, sir.
अभी like I guess mic में कुछ change हुआ
I think
अभी
my
just now.
it's a discharge. Yeah. Just wait. Am I audible to you? Guys, say
Sir.
something. Yes or no?
Yes, sir.
Sir.
Okay. Just give me 10 minutes. Let me. I think my iPods. Where is that? Okay, take 10 minutes break. Please take 10 minutes break. Just 10 minutes. Hello? Are you getting these values? I'm getting KB values 2429.58 Newton per meter. Up to 4 decimal like this one. And since these two stiffness or you can say springs are connected in series, it means that what? You have to calculate the K value. So in this case, what is K is going to be? Consider it's a K here. You can write it's a KB. into K divided by KV plus K. So if you simplify it, I'm getting this K value is nothing what you can say 414.6636. Done? So what is the natural frequency? That's nothing but root of K by M. So omega n is nothing but you can say M is how much? 1 only? So 414.6636 divided by 1. Could you tell me like what is the natural frequency is going to be? 20.36. It's not 20.36. 329. 36? 329. 329. Radian per second. Up to how many decimal points they are asking? Okay, the options are given here. Okay. B 20.36. They are asking up to 2 decimal places, right? Okay. So up to 2 decimal places you can write omega n is nothing but you can say 20.36 radian. Done? Again. Why? Because they are asking in radian per second. If suppose they are asking in hertz, then what do you have to write? Fn, then you have to write natural frequency or linear natural frequency Fn is equal to how much? Omega n upon 2 pi. Like that you should have to calculate. Am I audible to you? Please comment in chat box. Is it coming? Okay. Okay. Let's calculate this one. A 0.5 kg mass is suspended vertically from a point fixed on the earth by a spring having a stiffness of 5 Newton per mm. Take care. What is given here? Stiffness is given in Newton per mm. So please don't make mistake because omega n is going to be what? Root of K by M. Done? The static displacement in mm of the mass is going to be, calculate this one. First try to understand. 0.5 kg mass is suspended vertically from a point fixed on the earth by a spring. Okay, you can draw the equivalent diagram like this. Let's say this is the mass M. This is the earth surface. This is the spring. What is the stiffness? This is the stiffness of this is nothing but 5 Newton per mm. Okay. Mass is how much? Here mass is given 0.5 kg. What they are asking? The static displacement. Could you calculate? Yes. Delta is equal to G. Yes, calculate it. Easily you can find it. Find out. Take your time. Simply see. Listen carefully. Gravitational force, or you can say weight of body, always acts vertically downward. Doesn't matter where this spring is acting. Means whether you are attaching at the top, whether this mass is hanging from a vertical spring, or the system is like this. In this case, the weight W is going to be M into G. That's a gravitational force which always acts vertically downward. Second thing, there is a spring. The spring is here. So because of this, what happens? This spring will feel the compression. What happens? Compression in this spring will take place. This case is just opposite of what? Opposite of this one. In this case, if you are attaching any mass M here like this, then the elongation of this spring will take place. The opposite case is what? It is something like this. When this mass is attached, or you can say it is acting at the top of this spring, what happens? The compression in this spring will take place. It means that what? The spring force will be up in the upward direction. How much it is? A times of delta. Say yes or no, sir. Some static deflection will be there. You can write mg is equal to K into delta. What is given? What they are asking? The static deflection. So static deflection is going to be mg divided by K. They substitute the value of mg and K. M is how much? 0.5. Say yes or no, sir. G value is how much? 9.81. What? Gadi or Gode? Meter per second square. Is that clear? What is K value? K value in this case, it is 5 Newton per mm. But please remember, Here G value you have substituted in what? In meter per second square. So I'm going to convert it into what? So I can write K is nothing what you can see 5 into 10 to the power minus 3 or 3. Take care of this. It's a Newton per mm. Is that clear?
Per mm minus, yes.
It's not 5 into 10 to the power minus 3. It is 5 into 10 to the power 3 Newton per mm.
Per mm.
Sorry, per meter.
Yes.
Remember, 5 Newton per mm is how much? 5 into 10 to the power 3 Newton per meter. Please take care. This is a common mistake. What is the value of delta you will get from here? Tell me. It's a 0.1. So I'm getting it's a 0.981 divided by how much? 1000. Could you check please? Hello, Ladke. So I'm getting delta U equal to 0.981 into 10 to the power minus 3. What gade or bode? It's a meter. It means that delta U equal to how much? 0.981 mm. So that's what they're asking now. Say yes or no, sir?
Yes.
Answer is coming or not?
Yes, sir.
Okay. Here it is coming 0.97 to 1.01 and we are getting it's a 0.981. So our answer is within the range, and since they are asking up to the 2 decimal places only, here you can write your answer. Delta means static deflection is going to be 0.98 mm. Is that clear? Check. Now, next question. This one again, it's a combination of you can see the series and parallel only, right? Now, these two springs are connected in what? Series or in parallel? These are in series. Now, here we can mark the system like this. This is nothing but 4. Each and every unit here is given in what? Newton per mm. Is that clear or not?
Yes.
Take care. Here, I'm considering this is nothing but K1. How much? K1. What is this K1 is going to be? K1 is going to be, or simply you can write K1 is equal to, okay, don't write it's a K1. Let's say it's a K1 and this is K2 and I'm considering this is K3. Done? So here K1 and K2 are in series. Is that clear?
Yes.
Say yes or no.
Yes.
So let's say I'm considering this K1 prime here. I can write that's a K1 K2 divided by K1 plus K2. Let's calculate what this K1 prime is going to be. How much it is? 4 divided by 4. 4. 1. Are you getting 1? Or simply you can write this 1 upon K1 prime is equal to 1 upon K1 plus 1 upon K2. Still how much you will get? 1 by 2 plus 1 by 2. Again you will get to 1. Done? Now here we are getting it's a 1. Mass here is how much? M. Here this 4 and 1 are connected in what? Tell me.
Parallel.
Connected in parallel combination. It means that what is the equivalent stiffness? Ke I can write. Ke I can write here. That's nothing but 4 plus 1. If suppose if you are considering this is K1 prime and this is nothing K3 is equal to 4. What I can write? Ke is equal to K3 plus K1 prime. So what is K value? K3 is how much? 4 plus 1. So K value is how much? 5 Newton per m. Are we getting
Yes.
the answer? With yeah.
Yes, sir.
It is 5 only. Done?
Yes.
The GATE 2016. Next, this one, right? Hello? Am I audible or not? So in this case, since we have discussed these all things earlier,
Yes.
so what I can write? I can write the equivalent system is going to be what? Tell me. Yes? I can replace this by a single spring, which is nothing Ke. How much? That we have to find out. So that's nothing what you can say mass M. So what is this K is going to be? K is going to be anyone? K1?
K1 cos 45.
Huh? How much it is going to be? Yes.
Cos alpha 1 alpha.
How much you will get this K?
Cos
Simply you can say, look, whenever any spring which is attached at an angle to the direction of motion of a body. So here, the motion of the body, that's the X, but here we are having the displacement in this body like this, right? Displacement is what? It's a vector. So obviously, the displacement in this spring and the displacement in this spring is not going to be X. It is going to be how much? x cos alpha. If alpha we are considering it's a 45 degree. Okay. So you can write directly like KE, since there are two springs, say yes or no, sir. This angle consider it's a alpha 1 and this is what? Alpha 2. So I can write here alpha 1 is equal to alpha 2 is equal to 45 degree. So yes, what I can write? K is going to be K1 cos square alpha 1 check karna plus K2 cos square alpha 2. Is that clear? Let's check whether we are getting the values or not. Definitely we'll get the answer. So what is this K1 value? Yes, everything is given. K1 is K. Identical. Both are identical. So cos square 45 plus K cos square 45. So what is K is going to be? K by C. What is cos 45? That's a 1 by 2. So square of this is going to be 1 by 2. So simply you can write that's a K by 2 plus K by 2. So K you are getting that's a K only. Could you verify please? Hello, okay. Could you verify? I'm getting this K is nothing but you can say K. What is the natural frequency is going to be? Tell me. Natural frequency is going to be root of K by M. Done? Yes or no? Yes, sir. Now, what they're asking? The natural frequency of the system suspended by two identical springs. Okay. Of stiffness K shown in figure is given by omega M. Okay. Omega N is given here A root of K by M. Very good. For a small displacement, both these springs make an angle 45 degree with the horizontal. The value of A is, just compare what is the value of A is going to be. A is going to be 1 only. That's the answer. Look at what is the range of answer is given here. 0.95 to 1.05. It means that whatever we are getting is correct. So in these kind of the questions, please remember whenever it is inclined, what you have to remember? Its equivalent stiffness is going to be what? Or you can say in the direction of motion of a body is going to be what? K cos square alpha. In this case, there are two springs. Then it is going to be what? Summation of these two, K1 cos square alpha 1 plus K2 cos square alpha 2. Alpha 1, alpha 2 here, it is given 45 degree. If you simplify it further, we are getting K equal to K. So the answer is going to be A equal to 1. Is it easy or tough? I think it's a very easy question. Yes. Now, could you check? Hello, guys. Hello, online class. Am I audible?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
thank you. Now I can hear you. Okay,
सर प्रीवियस स्लाइड दिखाओ ना एक बार.
previous slide. Okay. ये क्वेश्चन ओ आ गया. ये वाला क्या प्रॉब्लम है बताओ. निकिता, दिस वन.
सर वो आंसर चेक करना था इसे.
ये देख के ही पता चल जाता है इसमें क्या आंसर को चेक करना है बच्चे.
मैंने सॉल्व किया था वो चेक करना था.
Okay, so are you getting 5 or not? Please confirm first. Are you getting 5?
गेटिंग सर. यस सर.
Okay. Which kind of link is this? It's a rigid link. Is that clear? Rigid link means what? Means the rod, or you can say the connecting rod here is having, if nothing but you can say rigid means what? Having the stiffness infinite. There is no relative motion between these two masses. So what is the degree of freedom is going to be? 1 only. Is that clear? Now here, in this case, I can take this system like two masses are nothing but you can say 6 plus 4 is going to be 10 kg. And here, this is going to be like this only. Done? So it is 20 Newton per meter and this is 20 Newton per meter. Which kind of, you can say, the spring combination is this? Is it parallel or is it going to be series? It is parallel only. We have already discussed. Means what? If suppose, if you are displacing this body by x, then the same amount of the compression and elongation in this spring takes place. Means what? Deflection is going to be same. Yes. Is that clear or not? Yes. Deflection is going to be same. It means that what? It is connected in parallel. So in this case, it is going to be next one. We can write The system is going to be like this only. And this is nothing but you can say 20 plus 20 is how much? 40. So what is a natural frequency? Are they asking natural frequency or something else? Again, it is in radian per second. So omega n is equal to how much? Root of k by m. The substitute. So in this case, it's a k e by m. So k value is how much? 40 divided by mass is how much? 10. So it is going to be how much? Root 4. Root 4 means what? 2 only. 2 radians per second. That's the answer. Are you getting? It's very easy. A 1 meter long, again, underline. What they are saying, it's a massless cantilever beam, oscillates at 2 hertz. Kritika, are you there? Kritika, are you there?
Yes, sir.
Which frequency is this? Angular or linear?
Linear frequency.
Linear frequency. Which one? Fn is given. Now your doubt is clear or not?
Yes, sir. Clear, sir.
Very good. So in this case, Fn is given 2 hertz, right? At the same time, the length of this beam, they are considered, say, 1 meter. They're saying if 60 kg mass is attached at the tip of it, which kind of beam is this? Cantilever. Weightless, or you can say massless. So here we can consider W is equal to how much? It is 60 G. How much, Ladke? 60 G here. What is the deflection of this beam is going to be? Delta U is equal to WLQ divided by 3EI. Done? Very good. Okay. The flexural rigidity of the beam is, what do you mean by flexural rigidity? Please remember in structure we are having 3 things. Flexural rigidity, then axial rigidity and torsional rigidity. So AI is the bending rigidity or flexural rigidity. So these two terms together tells us about, you can say, the material properties and cross-sectional property of a structure. Means I here, that's a moment of inertia, that's a cross-sectional property. And E is what? E is nothing but you can say material property. Similarly, we are having EA. Let me remind you again, once again, since we have discussed these all things lots of time, right? I think it's the 3rd or 4th revision of the same topic. E again, what is this? That's a Young's modulus of elasticity, right? Material property. Area is what? Again, it's a cross-sectional property. This is known as what? Axial rigidity. So axial rigidity comes into the picture when we are dealing with, you can say, the bars. Which one? Bar means change in length is equal to how much? PL divided by AE. If you are having any bar, or if a load is acting to its longitudinal axis, or you can say the axial axis P, then what is the change in length of the system? Delta L is equal to PL upon AE. So in this case, the change in length is inversely proportional to what? AE value. If A is high, then the elongation will be low. Is that clear or not? If A value is low, it means that the elongation of this body or change in length of this body is going to be high. In case of beams, generally we are having the beam equation is what? M upon I is equal to sigma upon Y is equal to E upon R. If you equate the first and third, what is the significance of this EI is going to be? Look carefully what I want to convey. If you equate this, I can write M upon I is equal to E upon R. Is that clear? Say yes, sir, or no, sir, first. So what is this R here? R is nothing but you can say radius of curvature. Then what is the value of curvature is going to be? K is equal to 1 upon R. That's how we define. Hello. If capital R is the radius of curvature, then the curvature is going to be what? Yes. 1 upon R only. So from here, could you tell me, like, what is the 1 upon R is going to be? Yes, Larke. 1 upon R is going to be what? M upon EI, na? Hello? Are you getting this or not? And this 1 upon R is nothing what you can say. That's a K, curvature. Please take care. I'm taking it's a small K, okay? That's a curvature. Don't write it's a stiffness. So M upon EI. And what is M? M is equal to how much? Minus EI into d2y upon dx square. And another expression is like that only. Is that clear or not? So here, If EI value is high, then the curvature is low. If EI value is low, it means that the curvature value will increase. Is that clear? So this is what? This is the curvature of this beam only? Say yes or no, sir? So if the EI value is high, then the deflection is going to be low. Are you getting?
Yes.
Is that clear or not? If the EI value is large, then the deflection is low.
Yes.
Right? Or you can say if the EI value is low, then deflection is large. So it simply talks about, you can say, the characteristic of any beam. Means that's a measurement of, you can say, that's a significance, or you can say characteristic of, you can say, the flexure rigidity, or you can say the bending rigidity. In case of shafts, generally we are having T upon J u is equal to tau upon R u is equal to G theta upon L, where L is the length of shaft. If you equate these two, what you will get, Larke? T upon J u is equal to how much? G theta upon L. And from here, what you can write? Tell me. Tell me, please. Angle of twist, theta, is going to be how much? TL upon GJ. So the angle of twist, or you can say twisting of the shaft, is inversely proportional to what? GJ. That's a torsional rigidity. Is that clear?
Yes.
Are you getting this one or not? This one or not? Please take care. In structures, or you can say in strength of material, these three parameters are most important. GJ, EA, and EI. Means these together tells us about the material properties and the cross-sectional properties of a system combinedly. So simply they are asking the flexure rigidity or bending rigidity, which is nothing but EI. How to calculate? Simply, okay, first let's write down what are the, you can say, the other parameter. Mass is given, okay, mass is given 60 kg. Okay, boss. The flexure rigidity of the beam means EI is required. How to calculate this one, ladke? Yes, bachi. And please remember, in which unit they are asking? Kilonewton meter square. If you don't want to make the mistake, please substitute the value in what? Huh? You can say in SI units you should have to put. In short. Okay. So here, what I can write? Delta U is equal to G by, sorry, omega n U is equal to root of G by delta. Done. Substitute here. So natural frequency is given or not? Okay, we have to calculate. Omega n is equal to how much? 2 pi Fn. Say yes or no, sir. So Fn is going to be how much? Could you help me, please? That's a omega. No. Fn is given now. So we can calculate omega n is equal to. Am I right? Am I right or not?
Yes.
So 2 pi into 2 is going to be how much? I'm getting 2 pi into 2. That's nothing what you can say. That's a 4 pi. What? Gade or Gode? It's a radian per seconds only. Please take care of it. Done. Substitute this value. It is going to be 4 pi. Kitna ladke? 4 pi is equal to G. Keep it G as a G only. And what is the delta value? That's nothing but WLQ by 3EI. So you can write here 60G LQ divided by 3EI. Done. Substitute here. So that's a 60G LQ divided by 3EI. This G and this G is get cancelled. So ultimately, what we are getting? 4 pi square. This is square on both the sides and simplify it. I'm getting this is 3EI divided by how much? Bachchi bata? 60 LQ. But say yes or no, sir? Yeah, bola karo, aise nahi chalega. So from here, I can write EI is equal to how much? Please bata de bachche. 16 pi square into how much? 60. L is how much? Could you help me? L is given 1 meter. So 1 Q is going to be 1 only divided by how much? 3. Just calculate and let me know what is the value of EI is going to be in this case. Could you simplify it, please? Where is my calci? (16 into pi square into 60 divided by
3.158 kilonewton.
I'm getting this value is 3158.2734 something.
Yes.
Are you getting this one?
Yes, sir.
3408 like that. So let's up to how many decimal places they are asking? Up to 2 now. Okay, no issue at all. It's in kilonewton now. So this is what? EI value is in this is in Newton meter square. Please take care. Now, if suppose they are asking kilonewtons, what I can write here? It's a 3 point, how much? 3.1583 kilonewton meter square. Done. So up to 2 decimal places, I can write it's a 3.16 kilonewton meter square. Please verify whether we are getting the answer within the limits or not. What is given here? 3.10 to 3.20. It means that whatever we are getting, that's a 3.16. It's a absolutely correct value. Is that clear? Say yes sir or no sir. Hello.
Yes, sir.
Yes, sir.
Thank you. What's the time? Huh? It's okay. We are revising now. Huh? I think it's a third revision if I'm not wrong, right? It's a third revision. In the spring mass system shown in figure, mass is given 3 kg and stiffness K is how much? 20 kilonewton per meter. The natural frequency of the system is going to be simply, look, these two are connected in what? Huh? These are in series. So simply you can mark if K and K are in series, it is going to be what? K by 2 equivalent of this. So you can write that's nothing but in K by 2. Mass here is M and this is nothing but you can say the K. Done. So what I can write? I can write here, let's say the system is like this. If this is K by 2, this is K. These two springs are in what? These are in parallel. If these two are in parallel, it means that what? Tell me, what is the equivalent stiffness is going to be? K plus K by 2. How much? 3K by 4 or 3K by 2 or 3K by 6? It's going to be a simple Siva. The 1 plus half is going to be a 1.5 only, na? Say yes or no, sir. So that's a 3 by 2 only. Mass M is M only. Done. So what is the mass, Prabhu? Huh? Prabhuji, mass is 3 kg. Is that clear? And K is how much? Again, it is given 20. So what I can write? K is nothing but you can say 20 into 3 divided by 2. Are you getting K is equal to 30, ladke? Hello? Please take care of the unit. Okay, so the natural frequency is going to be how much? Root of K by M. Are they asking in hertz or okay? They're asking in hertz. Okay? इसी से कर लेना. Omega n is equal to how much? Please tell me. That's a 2 pi Fn. बोल yes sir or no sir लड़के. So Fn is equal to how much? Omega n upon 2 pi. So I can write here that's a 1 upon 2 pi here. How much? Ke. So Ke is how much? 30 divided by mass is how much? Mass is given 3 kg. Please take care while you are substituting this value. Oh, it's a wrong. It is given 20 kilonewton meter. Is that clear or not? We are making mistake. It is kilonewton per meter. This value should be in what? In Newton. Let me write here. K is nothing but we are getting it's a 30 kilonewton per meter. It means that what? 30 into 10 power 3 Newton per meter. Divided by how much, ladke? That's a 3. So I'm getting Fn is equal to how much? 1 upon 2 pi root of how much? Huh? 10 to the power 4. Is that clear?
Yes.
Calculate this one. Ten into 10 is 100. 100 into 100 is how much? 10 to the power 4 only. Say yes or no, sir. बोला करो यार ऐसे नहीं चलेगा. 1 upon 2 pi into how much you will get? That's 100. 52 is 100 only, so that's a 55. How much, bacha? 55. Are we getting? Huh? Okay, something is wrong. Not 50 upon 55. That's a 50 upon pi, na? Extremely sorry. 50 upon pi. So what is 50 upon pi is going to be?
15.91.
50 divided by pi. I'm getting 15.9154 something.
Yes.
15.91549. So what is this value? Fn you can write easily. That's a 15.92 hertz. Up to 1 decimal point. What you can write? Fn is equal to 15.9 hertz. So what is the nearest integer value? Nearest integer value Fn is going to be 16 hertz. So that's the nearest integer value, or you can say integer value. Are we getting the same value or different? It's the same only, right? Exactly same value we are getting. Done?
Yes.
Shall I change the slide? क्या नाम है बच्ची का? चुप रहे तू. अरे वो SRM यूनिवर्सिटी वाली बच्ची का क्या नाम है? नो. Nikita. Hello. Shall I change the slide? Nikita, are you in the class? Shall I change the slide or not? Yes or no? Okay. This question we have already done. Say yes or no, sir. This question already we have done. Say yes or no, sir.
Yeah.
Okay. Now, the last thing which I want to convey, since one case is remaining now, we have taken a case where the mass of the rod we have taken and a spring was attached at the distance of A from the hinge. So we can have A value is L by 2, L by 4, 3L by 4, or A is equal to L. But what about the point mass like this? Let's say this is a point mass, right? That's what I want to convey. I have given the direct result, right? Say yes or no, sir. But let's prove it. What is the mass here? M. What I'm considering, let's say this is a hinge point. The length is nothing but you can say capital L in this case here. Okay. Now calculate what is the natural frequency. What I'm considering this is rigid and massless. It's simply, what is this, bache? This is nothing what you can say. This is nothing what you can say. Simply what? This is a rigid rod, and we are not considering the mass of this particular rod in this case. Done? How to tackle these kind of the problems? Simply consider, let's say this body is displaced by an angle theta from its equilibrium state, something like this. Done? And yes, one more thing, the system cannot hold on its own in the horizontal position. Why? Because this is hinged and a mass M is attached at this particular end, or you can say at the extreme end of it. It means that what? Something is needed to hold it in this particular position. So that's nothing but you can say spring A at a distance of A from this fixed end. Now, what the natural frequency is going to be? In previous case, how much we were getting? That's a Ka square divided by, yes,
I not.
yes, 3Ka square or simply K square. We
is 3K square.
no. We will get the same expression. Is that clear? Only the value of I naught is going to be changed. So please verify. I think it's a root of Ka square divided by I naught value.
Yes.
Right? Check. So let's check whether we are getting. I don't know whether. Please verify. Check the result ना. Notes check करना.
Yes,
जल्दी
sir.
बताना. ऐसे guess क्यों कर रहा है? What is the natural frequency we were getting? Yes.
Yes, 3K square.
Huh?
K square upon I.
K square upon I naught na.
Yes.
So in this case also we will get the same natural frequency. But please remember, in case of bar, when it is having the mass M, the I naught value was ml square by 3. But in this case, since it's a point mass, so what is the I naught value is going to be? That's going to be ml square. That's the only difference.
Yes.
Is that clear?
Yes.
This is the easiest way to understand, you can say, these kind of the problems. And the vibration is really very easy. Depends like how you are approaching this particular subject. If your basics or fundamentals are not clear, then you will get confused, you can see, in each and every question just by looking at. समझ में नहीं आता है क्या हो रहा है करके. Is that clear or not? वहां से थोड़ा दूर.
Wi-Fi,
No, not Wi-Fi. Some reflection is coming. Okay. So what is this natural frequency we can have? Okay. So we have given the initial displacement in this direction. Draw here, like what is the free body diagram? Let's say this point is nothing what you can say O we are considering. This is the direction of what happened. That's a direction of motion, right? What is the direction of acceleration? This is a theta double dot. It means that the inertia force will act. Okay, just wait. So the inertia force will act something like this. Sorry, inertial torque will act I theta double dot in this direction. Easy or tough? Just what is the inertial force? Sorry, inertial torque. That's a I naught theta double dot. Where it is at in the opposite direction of acceleration, or you can see the motion. If theta is the displacement in this direction, so theta double dot is going to be acceleration only. But which acceleration is this? Angular acceleration. So what comes into the picture? Torque, or you can say the twisting moment comes into the picture. If suppose it's a longitudinal vibration, what comes into the picture? Forces comes into the picture. That's it. Now, what is this K? When this body is displaced by an angular displacement of theta, could you tell me what happens to this spring? It will stretch. But why? What amount it will stretch here? You can consider that's nothing what you can say X only. Same approach. What is this X in this case? That's nothing what you can say. That's a into theta. Why are you waiting for? Then you can mark here. What is the spring force is going to be? Since you are stretching, if you are displacing this body in the downward direction, obviously the elongation of this spring will take place. If the elongation in this spring takes place, it means that what? The spring will try to restore the body. Means what? Here, the force induced in this spring is nothing what you can see in the vertically upward direction only. So here you can write that's nothing what you can Fs, which is how much? K into X. What is X here? K into A into theta, or simply you can write that's a Ka into theta. That's nothing what you can say Fs, right? Apply equilibrium method. How much time it will take? Less than 2 minutes to answer these kind of the questions. What? Inertia torque? Right here, IT plus external torque should be equal to 0. This is nothing what you can say. This is a external torque. What is inertial torque? This one. Just write down. That's a I naught theta double dot plus how much? Ka theta into how much, bacha? What is this moment arm is going to be? That's going to be A only. Just write here. How much will get? I naught theta double dot plus Ka square theta equal to 0. 10th और 9th का बच्चा भी इसको कर लेगा आके. Is that clear or not? कुछ बड़ी चीज नहीं है ये. So theta double dot plus K square divided by I naught theta equal to 0. Now just compare with the fundamental equation of simple harmonic motion. What we can write here? We can write the natural frequency is going to be Ka square upon I naught only. Look, are we getting the same result or not? Yes, we are getting the same result. Let me show you what I'm talking about. Which question I'm talking about? Anyone? We are talking about this particular question or this particular case. In this case, what we have considered? We have considered a rod something like this. A rigid rod having the mass capital M and length is L. What is the natural frequency we were getting? We were getting K square upon I naught. So in both the cases, we are getting the same natural frequency. But please take care. Technically, they are not same. Is that clear? Why? Because the I naught value in this case, it's going to be ml square by 3. But this expression is going to be same. K square by I naught. Done? I naught value in this case is ml square by 3. But when it's a point mass, it is going to be how much? Ml square only. That's it. It's easy to understand. What happened? Yes, are we getting this one? Yes. Now in this case, could you tell me like what is the I naught value is going to be? That's a have we taken capital or small as ml square, right? The substitute here, we can write that's a Ka square divided by how much? ml square. Now, so what are the cases? Write down case one. Yeah, A is equal to, let's say this spring is attached at the midpoint of this, you can say this massless rod here. Let's say A is equal to L by 2. So the case is like to be like this only. Really, it's a very easy problem. It's a L by 2. This is also L by 2, having the length L here. Okay, and the mass is attached at this particular point. So could you tell me, guys? This is the A value. What is the omega n is going to be in this case? That's a K. A is equal to L by 2. So that's a L square by 4 into ml square. So this L square and L square is going to be, sorry, so we are getting, that's a root K divided by 4. Again, what is the unit? Radian per second. If suppose they are asking in hertz, apply the formula omega n is equal to 2 by fn. Fn is equal to omega n upon 2 pi. That's it. Second case, let's say A is equal to, that's a L. So which kind of system is this? Let's say the mass is also acting at the extreme end of this rod. At the same time, this spring is also attached to it. At what location? A is equal to L, means at the extreme end. So in this case, just substitute here A is equal to L value in this formula. What you will get? Omega n is equal to root of KL square divided by how much? Tell me. Yes? Tell me. How much you will get? ml square. So simply, it's a case of K by M only. Is that clear or not? Done? If suppose A is equal to L by 4, you can substitute and find out. Is that clear? Please take care. Okay, consider one more case. That's a third case. A is equal to L by 4. Could you tell me that what is the nature of frequency is going to be? That's a KL square divided by 16, right? ml square. So this L square and L square get cancelled. Ultimately, we are getting how much? 1 by 4 root of A by N. And here, this one we can also write now. It's a 1 by 2 root of A by N. Is that clear? Yes. So I think that's a end of the lecture. I think we saw all the PYQs which they asked based on what? Based on what? Okay. Okay, one more thing. अभी flow में है ही तो देख ले थोड़ा सा. If you don't find. Okay, write down what is the equation of motion. Let's say here this is K. Done. Hello. And let's say we are having the damper. Total length is capital L. This is A. Let me check how many of you like understood or really understand like how to write down the equation of motion. Yes, tell me. लिख के बता मेरे को. Just apply the equilibrium method, or you can say the D'Alembert method to write down the equation of motion of, you can say, this kind of system. Consider C is the damping coefficient, K is the stiffness. Done. Find out. I'm considering, listen, I'm considering in this case what? Tell me. I'm considering it's a rigid var having mass capital M. So what happens? What is the inertial torque? Is going to be I naught theta double dot. Say yes or no, sir? Yes. What is the moment created by this, or what is the spring force is going to be? Yes, tell me. K. Huh? Kx, K theta. Tell me just. Okay. K theta. Okay, okay. Okay, K theta. And what about this one? What is the unit of this C? Anyone? What is the unit of this C is going to be? How we define the damping coefficient? Huh? That's a force per unit velocity, F upon V. So it is going to be how much? Newton second per meter only. Is that clear? Please take care of it. How we define C is equal to F upon V. Here V is nothing but fluid velocity in the dash spot, or you can say in the damper. So it is going to be Newton per meter second. So this unit you can write it's a Newton second per meter only. Right on. How much? क्या लिखा है?
सर पूरा इक्वेशन बता दूं, अपना डीएल एम्बेड मेथड की बात लगाया है।
हाँ, करके दिखा यहाँ पे। नहीं दिखाना यहाँ पे आके। वो मेरे को क्या बता रहा है? इक्वेशन मोशन बता फिर मेरे को क्या आएगा? इट्स अ वेरी सिंपल। Okay, check on your own. Let's say a very small deflection theta is given to, you can say, this particular system. Then what is the displacement in the spring is going to be considered? That's nothing but x, which is nothing but how much? A theta. If x is equal to a theta, okay, very good. Now, what is the displacement here is going to be? Yes, here. Tell me.
Theta into L.
Huh?
Theta into L.
It is going to be L into theta. Say yes or no, sir. Consider. Okay. Let's say I'm considering this is the delta of a spring. That's a delta S, or you can say X is going to be, that's a A into theta, right? Look here. What is this value is going to be? Anyone? Tell me. This total is L from here to here, right? And how much displacement you are providing to it? Theta. So what is X at the end is going to be? That's a L into theta. Na? So say yes or no, sir. The length of this object is not going to change, or you can say position of this is not going to change. So what is the value of X dot is going to be? Anyone? Okay. What is this X dot is going to be? Yes, L into d theta upon dt only, na? That's nothing but again L theta dot only. Done? But say yes or no, sir. So here what I can write? I can write here, let's say this is a point O. What is the spring force is going to be? That's a Fs. What is the damping force is going to be? That's a Fd. What is that? Fd. What is this Fd? That's nothing C into X dot. What is this Fs is going to be? K into X. Is that clear? But say yes or no, sir. And what is the direction of motion? This is the direction of motion, or you can say it's a theta dot and theta double dot at any instant, or you can say at any time t. Then what is the direction of inertia? Torque is going to be IT is equal to how much? Please bata de ladke. Yes. Tell me.
Not theta double dot.
Sorry. I naught theta double dot. Simply. So what is the I naught value in this case again? That's a ml square by T only. Just substitute here. So what I can write? Summation of inertia torque plus external torque should be equal to 0. So what is the inertia torque here? It's a very easy. Doesn't matter whether it's a 2D system or whether it's a single degree of freedom, 2 degree of freedom, whether it's a damped motion or you can say the undamped motion, you will get these all things very easily. What is the external torque is going to be? Please help me. Okay. You will get the external torque from spring as well as from the dash spot, or you can say from the damper. How much it is going to be? That's a K into X into how much? Sorry, I'm writing KXA only here. Is that clear? And we can substitute later on. It is X equal to into theta plus how much?
C.
That's nothing. C into X dot. Plus FD into how much? X dot is equal to 0. Is that clear? Say yes or no, sir. So, hey, is it correct?
Distance, momentum का distance रहेगा ना, तो वो तो L ही होगा.
Oh, you are right. FD
into
into L. Yes, extremely sorry. So I naught theta double dot plus
K square theta.
KA. X is how much? A into theta, right? Say yes or no, sir. FD is equal to how much? CX dot, and X dot value is how much? L theta dot. So here I can write that's a C. X dot is how much? L theta dot. Well, yes sir or no, sir?
Yes.
Into L u is equal to 0, I naught theta double dot. So how much you will get? You can write CL square are you getting? Okay. CL square theta dot are you getting? Plus K square theta u is equal to 0. Are you getting this one or not? First say yes or no, sir. Hello, theta double dot plus how much? CL square divided by I naught theta dot plus how much? K square divided by I naught theta u is equal to 0. So the question is that how to calculate the frequencies and damping ratio of these systems. Then what I suggest, just write down what is a second order differential equation for which motion? For the damped system. What is that? In terms of x, or you can say s, it is going to be s square plus 2 zeta omega n, right? Say yes or no, sir. 2 zeta omega n s plus omega m square is equal to 0, if I'm not wrong. Say yes or no, sir.
Yes, sir.
Is it correct or not? It is correct or not?
Yes, sir.
Huh? What's the equation? S square plus 2 zeta
2 zeta omega n
s plus omega n square
omega
is
n
equal
square
to
equals to
0. Right? That's the equation now. We can also substitute here the solution and we can write it is going to be simply s square plus 2 zeta omega n s plus omega n square is equal to 0. Okay, could you verify this first?
yes, sir.
I'm not sure.
Empty.
X is equal to L into theta. Okay. Okay. X is equal to could you check it, please? Could you verify from your side? Hello? Those who are online, could you verify this from your end also, please? Take your time and just verify whether we are writing the equation of motion in right way or not.
Same equation are.
Are you getting the same one or not?
Yes, sir. Same.
Okay. So what we generally take, we can also write down this in this particular form, like you can see the form to get the solution or to get the omega n and zeta value. So see, in case of, you can say the longitudinal vibration, we took the solution is what? X is equal to e raised power t, e raised power st. Say yes or no, sir.
Yes.
Here also we can take, let's consider theta is equal to how much? E raised power st only. If theta is equal to e raised power st, could you tell me, like, what is the theta dot is going to be? E raised power st into, tell me. Yes, tell me. D upon dt of what? S into t. So it is going to be what? S into e raised power st. Are you getting? First say yes or no, sir. Similarly, what is the value of theta double dot you can write? It is going to be s square e raised power st. If we substitute here in this equation, the value of, you can say, theta dot and theta double dot, what you will get, ladke? You will get this theta double dot is nothing but, you can say, e raised power st s square, right? Plus how much? Please बता दे बच्चे. Yes, yes. बोलना कुछ. S into e raised power st CL square divided by I naught plus it is going to be K square divided by I naught. कितना? E raised power st. What is common? See, in this case, since we are considering the solution of this is e raised power st, so e raised power st cannot be equal to 0, right? It's a simple mathematics only. So e raised power st is common in each and every term. It means that what? The only thing which is possible in this case is nothing what you can say s square plus how much? Hello? We can replace this by s square plus TL square divided by I naught times of s plus ke square by I naught is equal to 0. Now, are you getting why I was like comparing this by directly? s square plus, that's a 2 zeta omega n plus how much? Omega n square is equal to 0. So this is what? This is a, which kind of equation is this? This we are getting from the damped free vibrations only. We were getting the equation mx double dot plus cx dot plus kx is equal to 0.
Yes.
So that's a linear second order differential equation, right? And the solution of that we have defined in terms of this only, right? So here, this angular displacement also, or acceleration and velocity also, we have defined in a common terms. That's nothing but you can say as here. If we compare, what is the value of 2 zeta omega n is going to be of this system? Pata na ladke? What is 2 zeta omega n? Just compare this s term with this s, compare this omega n square term with this particular term. So what is the natural frequency of this system is going to be? Tell me. Simply omega n is equal to root of kitna? Ka square divided by I naught. Yes. And 2 zeta omega n is how much? It's a very easy. कुछ भी नहीं vibration में. CL square divided by, tell me. Yes. I naught. So the question is that, like, how to simplify it? It's very easy. Either you can substitute the value of omega n, or you can take the ratio of this. Depends what you want to convey or what you want to calculate. Done. That's a natural frequency. If you know the natural frequency, if the k value is known to you, a value is known to you, I naught value is known to you, calculate the omega n value. C value, definitely it is known to you. L, you know, like what is the length of, you can say, what is the length of, you can say the beam, or you can say var. It is already provided by the examiner. I naught value you can calculate easily. So from here, what you can write? Zeta is nothing what you can say, that's a CL square divided by, yes, 2 I naught omega n. That's it. Each and everything is in front of you. And what is this zeta? This zeta is nothing but C upon Cc. Okay. Thank you, all of you. That's we are going to solve like few more questions in coming lecture. If you are free, shall I conduct the lecture like in late night around 9 o'clock or 10 o'clock, if you don't mind? Hello? Bolo, yes or no?
Yes, sir.
Okay. I will update in the group. Okay. Thank you, all of you. Okay. One more announcement. Like, please complete the deflection of beam, unsymmetrical bending, and symmetrical bending. At the same time, the torsional shear flow as well as the flexural shear flow as soon as possible. Since we have done these all things already, you have to keep on revising the things. Okay. Now I can leave. Thank you, all of you. And yes, for GATE 2027, I'm starting the new batch from the February. Those who are like interested can join the classes, and the registration is starting from, you can see, the 23rd of January. That's on the occasion of, you can say, Vasant Panchami. Definitely you will get the concession or discount if you are joining from the January onwards. Thank you, all of you. Stream. देखना streaming and doing क्या